First, Wolfgang Hasper of the Passive House Institute in Darmstadt will outline the basics and recent developments in applying Passive House principles to school buildings. Then we'll go to Northern Ireland with Barry McCarran and the new Passive House Premium Campus at Southwest College. We'll circle back to public schools in Scotland and the revolution Anne-Marie Fallon and her teammates are instigating there. And after the presentations, we'll have a talk incorporating audience questions. After that first part, we'll have a 10-minute break, and then we'll come back and bring it stateside to a bevy of activity in the Northeast. First in Portland, Maine, with Naomi Beal and Richard Lowe, then a trio of school developments from Timothy Locke. Our final presentation will be on how New York City school systems is diving, the New York City school system is diving into decarbonization with Caleb Crawford and two pilot New York City Passive House schools from Dominic Griffin. And after that, we'll have another panel discussion and bring in some questions as well. So with that, it's my pleasure to turn over the presentation to Wolfgang Hasper of the Passive House Institute to get things started.
Well, the situation a good 20 years ago in Germany and Austria was like Passive House had proven itself and was increasingly becoming interesting for the non-residential building types, including schools. Passive house technology basically was known, but applying it to a building type with completely different characteristics posed some challenges, which I will outline to conclude finally with a bit the situation we have achieved now. So there were a number of pilot projects where Passive House was put on the agenda for a new school building, mostly public schools, but also a private school. And all those design teams, they more or less got in touch with us, but had to develop many things for their own. There quickly arose the need to summarize all these findings, discuss, and put it in a more systematic framework in order to streamline the design process in order to make it a lot easier to replicate. This happened, and these were some of the central questions that had been under discussions. For example, how do internal heat gains differ from residential applications? What flow rates are adequate? How do they relate to the age of students? And of course, non-residential buildings in general and school buildings in particular, they all have an intermittent operation pattern. So they are normally shut down after school and sit idle for the night and weekends. There are holiday times. This brings about new concerns, for example, with MVHR operation, with temperatures, and the question of hygiene in filters in the MVHR. Further, it was interesting to discuss what the importance and impact of thermal mass was in schools. We know that it is not so very relevant in residential applications, but might differ in schools. And then in connection with schools, we many times have gyms which have yet different demands, and kitchens and cafeterias as well. They bring about their specific challenges. All this led to very interesting discussions in the lively session of the working group on cost-effective passive houses then in 2005. And I will illustrate this with a few slides, some even dating back to 2005, just for the look and feel of the early 2000s. The first question was, what about internal heat gains and how do they relate to the age of students? Turns out that this can be fairly easily answered with Kleiber's law that relates body mass to metabolic rate. And so you can easily calculate this particular contribution to internal heat gains from the age of the students, more or less from first principles. And also we have measured data from carbon dioxide concentration in classrooms. I will come to that in a minute, which also is an indirect measurement of the physical activity. From that derived is also the question of airflow rates that are adequate, and it boils down to 15 to 20 cubic meters per hour, depending on age, and as a rule of thumb, 500 cubic meters per hour per classroom, just to give a feeling for what's involved in terms of MVHR. Then the patterns of internal heat gains, they are really interesting to assess in a little detail. Because they are of a spiky nature. So in the morning when the class arrives, a massive amount of people and a massive amount of body heat is suddenly available. But if you observe it or take a mean value over a longer time span, including the nights and weekends, then the average internal heat gains are again fairly low and not so far from what we are used to in residential applications. But this very dynamic nature of internal heat gain is something that immediately relates to design choices, because a good access to thermal mass is very, very beneficial or even necessary to flatten out this a bit, and particularly in the summer, avoid overheating in the morning or during the day. Of course, it is a clear pro for passive house schools that we know that in existing schools with no real ventilation system, we have outrageous carbon dioxide concentrations and poor air quality in general. We all remember that from our school days, I think. And about one class into the day, the critical limit of carbon dioxide is already exceeded, and this feeling of drowsiness in the morning at school, that's not only due to lazy students, but it's really physically determined by this carbon dioxide concentration. So we can greatly improve the learning environment, not only in terms of thermal comfort, but also in terms of internal air quality, which that measured data clearly shows when we look at this plot of carbon dioxide concentrations from a ventilated classroom, where there is a little rise along the day, but it's not serious and it's still quite good air quality. Another thing to discuss was, due to this instationary nature of the building usage, this cyclic operation, what happens in terms of heating when the building has been shut down for the night in the winter, and do we get it warm again? Do we have to maintain it at 20 degrees all the time? Or what is the appropriate strategy to operate it in an energy efficient way, but meet comfort requirements at the same time? So this plot is a dynamic building simulation result for the critical case, where it was tested whether or not you can actually heat a school building with supply air heating alone, saving all pipe work and heaters. And even this is possible due to the relatively high airflow rates we require for so many people in densely populated classrooms. So we can, even after a weekend in the winter, reheat the building in time to be up to a comfortable temperature when class starts. You can see in the afternoon, when school is finished, that the building does lose temperature gradually and gets down to about 17 degrees at the end of the night. And this is some sort of a limit we shouldn't exceed. Stabilizing it at 17 degrees is a sensible design choice, but you don't have to maintain it at 20 degrees all the time, which of course has a great impact on the heating demand. These are a few images from a kindergarten where you can see where this leads. Since here we haven't chosen supply air heating, but heaters, but these are very small and can be located in an arbitrary spot. So it's really by the corridor wall to keep the pipe runs as short as possible. It's high up, so it's out of the way, and no one can hurt himself. And we can also see that some effort has been taken to keep most of the ceiling clear in terms of access to thermal mass. So there were some acoustic panels suspended, but the concrete ceiling is exposed. The hygienic operation with this intermittent pattern requires to dry filters and shutdown. Many methods are available and have been discussed. Some ventilation units these days have it even integrated. Otherwise, you need to provide the dampers and ducts. Most important is to have it on the list and not find out only after the building is finished. The question of gyms was discussed. These are high spaces, large room height much higher than the normal classroom, and whether or not do we have to fear temperature stratification. But it turns out that in a very well insulated building like the passive house, you don't have noticeable stratification. It's really very, very little, and the simulation results and what we can find with thermal imaging, like in the left picture, really is in very, very good agreement. So gyms are easily handled. They require slightly lower room temperatures since people have high activity. They can easily be heated with supply air heating if desired. Only normally you have transfer air to the changing areas where you would like to have somewhat higher temperature. So you will have an extra heater there to push the temperature from about 18 degrees to 20 degrees. A very important topic in schools is light, daylight, lighting, and the relationship to shading in the summer, to design shading devices that still allow enough daylight in the summer. So otherwise you might keep the sunlight out, but if you switch on the artificial lighting, then you get an extra load of internal heat gain, which you do not want in this situation at all. So you can see what strategies can be adopted to unite those two somewhat conflicting interests. Lighting in general is another thing, the artificial lighting. So to have a real bespoke engineering for the lighting fixtures, in order to provide the required illuminance, but not more, and evenly distributed, you can really save on this, or have a high potential on energy savings there. LED technology, of course, has brought about great advances, But still, this bespoke lighting engineering is something that really pays off. The example is taken from a gymnasium, but it also holds for classrooms as well. Lighting is a big contributor to the electric energy demand. And all this then led to schools becoming a fairly routine job in terms of passive house design. The passive house database yesterday contained 183 examples for schools and educational buildings. There are many, many, many more. It's just a fraction that is entered into the database, sadly. But even in this first row of images, you can see that these buildings are very different. They are different types of schools, different sizes of schools in France and Germany and Austria. Best have a look yourself into this database. It gives a good impression of what is possible. And hopefully there will be many more from North America very soon. Finally, of course, this is not only relating to new build. All the EnerFit strategies, refurbishment with passive house components, can be applied to schools as well. And as many schools are quite large structures, we can even achieve full passive house standard on the right image for a high school building that is making do with a few remaining stone and bridges. Because it is so large, it can still achieve full passive house standard. On the left, we see the refurbishment of the university building in Innsbruck University. So it is from kindergarten to university. The full scope of educational buildings can be covered with passive house technology. We will see in the following presentation to what scale this can be developed. There is a handbook which summarizes all these basic findings on how to address this non-residential building type for educational uses. Many hints, and maybe the English translation is not yet perfect, so we'll be happy for feedback. But I think it's still a valuable compilation of important aspects to consider when you start the design work for educational building. Yes, and that's more or less what I can present at the moment. I hope this evening will be a very interesting one for everybody, and I'm looking forward to the discussion later on. Thank you.
Our Earn campus, which we call it here locally, which is one of Southwest College's main estate buildings, and it is, well, it was at the time of construction, I think, the world's largest passive house premium building. And you can see there it's quite aesthetically pleasing, and you can see with the trained eye a lot of brise soleil and different things. The front, the facade there is south facing, but I'll come on to talking around that. And you can see in the background the sort of rural town that it's located in the form of Enniskillen. So for Southwest College, one of the main reasons why we pursued a building of this standard is really to do with, I suppose, overarching climate change and our role in that as a public body and as a college. And it really fitted hand in glove with the Department for the Economy here, who we sit under within education in Northern Ireland. So it was a win-win in all respects, really, to aim for the passive house standard. And as you can see there in the slides, you know, with building emissions accounting for 40%, you know, this really is an area to focus on, and Amory and others will come in on that as we go through this session. But another one for us that this really seems to have resonated with post completion for the building is really the UN Sustainable Development Goals as well. And again, this little bit of work that was done by the International Passive House Association really brings that home as well, with 8 of the 17 UN Sustainable Development Goals being hit. And For visiting organizations and other education institutes that come and visit our campus, this seems to be one of the areas that also really people take away, and policymakers have also took away as well. And again, at the end of my presentation, I'll go on to really articulate how our Earn campus here has really broken a glass ceiling with respect to public buildings in Northern Ireland as well. So again, why Passive House? I've sort of talked to this already to some degrees, but it's really one of the other things that I'd pull out of this presentation is the international dimension of the Passive House standard, and the fact that it is an international standard, and because here today I'm talking to the international community, it resonates even better again. But in some of the later slides, we'll talk about how we've leveraged that as well. Again, if there's an uneducated audience here within the group, I have to turn on. No, we're okay. We have the light on. Within the Passive House metric, we all know that there's 5 different classifications. So that's really a slide in there to train the uninitiated in that space. And again, because this building's premium, yeah. So yeah, as I'm saying here, we can see the 5 classifications, and of course Passive House Premium is at the top end of that, and the low energy building standard being at the bottom. So for us, this journey really started in 2013 with the emergence of this building you can see in the photograph, and for us being a college, we started to become an agent for Passive House, and delivered tradesperson courses and designer courses, and we've been in that space ever since. And that's really going very, very well within Northern Ireland, and also it's probably been a big building block of success as to why there is so many public buildings being built to the Passive House standard here in Northern Ireland as well. And again, I'll come on to that. This was the existing building that our new Earn campus replaced. This now has been sold to a private investor, but just before we decanted the building, we did some, I suppose, pre-monitoring before moving to the new building. This building was over 50 years of age. It was the worst in terms of building performance at a D category. All of us have no kilowatt hours here. That this was 152 kilowatt hours, so much higher than the 15 kilowatt hours of Passive House. And again, burning through 100,000 litres of oil a year in the home heating oil. And at the time, oil was very cheap, so that was costing £51,000 a year to heat the building alone, not including hot water, not including the electricity bill, just for heating alone, £51,000. But at the height of, I suppose, the different conflicts that broke out around the world, and how that impacted energy costs, that cost hypothetically would have went to over 100,000, would have doubled at least, if we were not to have decanted that building. So that just shows again
12 kilowatts.
Okay, so that just shows when relying on fossil fuels, just how exposed you are to commodities and different situations around the world. So the site it was on the site of an old hospital, and that's what was built there previous. And the college management wanted to pursue, as I said already, the highest and best standard that we could build to when we had the opportunity to build. So this is what way we set out, and that of course is Passive House Premium, but also this includes BREEAM Outstanding, which within the UK is one of the other classifications under energy performance that you can aim for. And then in terms of predicted performance, now again, this would need some revision in terms of costs since, but again, I did give you a picture of what the existing was, but with it now being a Passive House premium building, we have gone significantly lower in terms of our heating costs, and again, using sort of Passive House methodologies and extrapolating that over the lifespan of the building, which will be at least 25 years, if not 50 years, you're running and accumulating into significant savings over that time. The next few slides just talk to the building itself and the fabric, floor, walls, roof being the building envelope. You can see there in the red the various U values. We've got a glass facade, which you've seen in the first photograph, along with timber frame to the rear and to the sides. And again, you can see the various proportions there as well. So that's our thermal envelope. We also then, with thermal bridging, had a colossal, and you can see here in this next slide, 4.5 kilometers of thermal bridging was calculated for this building. You know, I often like to say when I'm presenting on the building, at the very same time as our building was built, there was other FE college buildings built in Northern Ireland, and they're of similar size and scale. So at least our building has 4.5 kilometers of thermal bridging that's not going to leak heat for the next 50 years. So again, it also shows to people who are not from a passive house background the significance of thermal bridging as well. When then looking at the glazing, again, to refer to the initial photograph, you've seen that amount of glazing to the front. Here we have the typical passive house metrics for that glazing in terms of G value, UF, UG, etc. And if I take your attention to the bar chart, you can see that over the course of the year, the windows are contributing or providing heat, which pushes down our heating demand in a bigger proportion than the amount of heat we lose through the windows. And again, when providing the teaching of this to people on the passive house designers or tradespersons course, they're often struck by that, because normally in little old Ireland here, you know, the windows are often seen as a very uncomfortable area of the building, and you know, to see the contrast in that is quite surprising for people as well. Also in the graph here at the bottom where my cursor is at the moment, we can see the proportions across the different orientations of the building as well. And again, from doing my own house to the passive house standard, it's quite important to minimise glazing to the north, and that's something that was prioritised in this building as well. Then moving on to air tightness, following the passive house principles. Our air tightness in this building, we were targeting 0.3 of an air change as opposed to 0.6. And this was because it's true to say that there is a bigger opportunity to achieve better air tightness with a larger building. And indeed, that's what we went for in this building. And for a team that had never built a passive house building before, they came in and achieved an air tightness of 0.36 at the first time of asking. So that was an excellent result. And again, you can see some pictures on site there with tapes and membrane to the timber frame elements of the building. The next slide is quite a complicated diagram because the ventilation system on the building is a little bit convoluted in some respects, but it does employ mixed mode ventilation in the form of mechanical and natural as well, which is quite unusual for a passive house building, but maybe not of a building of this scale. So again, if you follow my cursor, you can see that air enters, before it enters the building, which is the dotted line here, air will enter a subsoil heat exchange, and that will, again, we'll see that in the next photograph on site, but that will preheat or pre-cool the air depending on the time of the year. And then as the air then comes into the building, it will either go through a centralized or decentralized heat recovery situation. And then our atrium to the front with all the glazing is an area where we can purge ventilate with stacked ventilation. You can see there's opening windows up top here, and indeed a window is able to be opened at the bottom. So we use this as a buffer zone essentially for the classroom accommodation that's to the rear of the building, to the back of the building. So again, if there's any questions on that, I can take them afterwards. Here in this schematic, along with the photographs, we can see that the subsoil heat exchange going into some aerial shots there. And again, in this, there's a kilometre of subsoil heat exchange before that air enters the building. Then in terms of our heating arrangements, we have a bio-oil micro CHP unit, which provides about 80% of the space heating and 100% of the domestic hot water for the building. And you know, we also then have an air to water heat pump making up the other 20% of the space heating. So that's the arrangement that we have for the building. Now, again, some commentary on that post completion is that that was, I feel, maybe a mistake in terms of the experience since, and we would have been better maybe going a different route. But again, interesting learning for the Passive House community. So again, if anybody's questions on that, we can take them as well. This aerial shot's lovely. I really like this slide because it shows the amount of PV generation that there is on the roof. And again, this is a Passive House premium building, so that's no surprise. But it also shows a lovely relationship to the town of Enniskillen, and again, the mature trees and stuff that was around the old hospital site, and it really does complement the building. And I know some people on the call have been lucky enough to be here. And then with renewable energy, to just talk to some of the specifics on it, it's a 520 kilowatt P system. It does generate 120 kilowatt hours per meter squared, meeting the classification for Passive House Premium. And again, for people that are not familiar with that, it is the equivalent of about 14 tennis courts on the roof. So that's the amount of PV on the roof in particular. And then to complement this, we have some battery storage. And again, that's just to ride out the peaks and troughs and to take in when we have surplus generation, that power that can be used later. But what I have on this slide, which is quite interesting, is as well some post-occupancy data. So you can see here in year 2, we're almost 3 years now post-completion, but every year of data so far has been very similar to this. The building is phenomenally successful. You can see there in this column here, it's more or less 21 degrees on average every month of the year, which is exactly what it should be. Really good environment inside, and you can see there that in the summer there was some peaks. Now what's interesting about that is, and from monitoring the data, is that a lot of the ventilation is controlled by CO2. So in the summer, when we have almost no occupancy because we're a college, or only minimal occupancy with some staff and some departments, that actually slows down the ventilation. And what that means is that means that we're more prone to maybe an increase there with the slowing down of ventilation. The next slide is also really interesting to everybody here because of the topic in discussion today. We can see here across the whole year the indoor air quality data, and again, looking at that, the average for the whole year and subsequent years, it has been below 500 CO2 parts per million. And again, there we can see a consistency across all the months of the year. And this is excellent because as an education space in the form of a college, there's loads of data backing up better cognitive performance and everything else with excellent indoor air quality. And we can even see there with our maximum figures, we're not even crossing 1,000. And I seen in Hasper's slides in the first presentation there today that, you know, CO2 in schools readily would go 2,000 and above. Maybe even much higher than that as well. So, so far it's great for us. And in terms of the performance of the PV panels and the renewable energy systems, everything's working really well. All things said, again, the CHP unit will have a slight story in this as well. But we can see here across these graphs, and again, I'm happy for these to be shared after the event as well. People want to look more detail at it, but we're getting about 50% offset of our electric over the course of the year with having the PV panels, which is excellent as well. Again, sharing costs. I do think that in the college, we were very, very fortunate at the time that we built that. I don't think we could have got better value for money at a better time. Really, this was just before the supply chain increases in inflation and everything that came afterwards. But the building cost approximately 30 million, which worked out at about £3,500 per metre squared. And that today is excellent value by anyone's measurement. So again, considering the currency exchange at the moment, that's almost 1 for 1 in dollars as well. So just to give people or save people the anguish of having to convert that. And then for us inside the college, it's really helped with our day-to-day business in terms of the department that I head up. You know, we've almost done £1 million worth of research and development within the local economy in this space since 2015, which doesn't sound much maybe on a global scale, but locally that's quite significant as well. And then I think this is one of the most special arrangements that we've been able to leverage out of it all. And again, particularly that I'm speaking to North America, this is relevant because other institutions have, Cornell Tech there, for example, in New York or another. We've been able to reach out to our friends in North America, and Humber College up in Canada have retrofitted that building that we can see in the photograph here to the Passive House standard, and Penn State have a long-standing arrangement with the Passive House community as well. So we've been able to, organise student exchanges with both those institutions, and again, if there's others on the call, that's something we'd look to expand upon and hopefully have a two-way arrangement as well, where we're able to maybe bring people over to Ireland as well. We never knew that was going to happen as a result of building a building, but these softer things have fell out of it since, and they're very, very rich. And then we've also been able to, become part of a couple of different networks within, the UN, for example, and again, a subsequent entity that has arose out of this as well. So it's been very, very fruitful for us to have been an early adopter with Passive House as an education body into this space globally. And again, our research and our post-occupancy monitoring, we've been able to use all of that as well to present to various conferences around the world as well. So again, for an FE college in Northern Ireland, that's breaking new ground for us because we're not a university. And again, just sort of rounding out and concluding as well, we also, many of you will know on the call that we did host the boot camp for the International Passive House Association, but also in this as well, closer to home within the UK, we were invited into this network to celebrate the Queen's Jubilee by the Royal Anniversary Trust. And that had a very select group of about 20 institutions in the UK. And again, if we hadn't have built this building, there is almost for certain no way that Southwest College would have been part of that group. And again, we're an author on this document as well about how to accelerate the tertiary education sector towards genuine net zero. And we also have various other publications and stuff as well. But in concluding, and I think this is a very positive way to frame things for me, finishing up on this, I'm very proud of it as well. I suppose that I'll draw your attention to the bit at the bottom that's in bold and underlined. There is now, and it's almost 400 million at the moment, 400 million pounds of public buildings have followed Southwest College in Northern Ireland, and in Northern Ireland alone, to the Passive House standard as a result of this building. So we have Queen's University in Belfast City, who are building one of their large student apartment blocks to the Passive House standard. We have the library organisation in Northern Ireland called Libraries NI that have built two Passive House buildings or libraries since. And we have Belfast City Council, also in Enniskillen, another jurisdiction. They're building a new swimming pool to the Passive House standard, and we have a few other buildings in development. The Department for Agriculture have two large campus buildings being built as well. So it's a real story of success and something that even within Northern Ireland isn't fully appreciated yet. And I think the latest is we might have a planetarium that's also going to go to the Passive House standard. So a very, very positive picture here as well.
Right, so I'm just going to bring you through a little bit of the context of what's been happening in Scotland the last few years. So we're going over east of Northern Ireland and a little bit north to Scotland, where I've been based the last few years, developing Passive House and in particular Passive House schools in the Scottish context. So my name's Anne-Marie Fallon. I'm working with a practice called Archetype. We've been looking at sustainable design for about 40 years, but really Passive House, operational performance, guaranteed performance of buildings for the last kind of 15, 16 years. And we, as a result of the Scottish government's kind of more ambitious climate policies over the last 5 or 6 years or so, developed an office of 35 strong in Edinburgh over the last 4 years as well. So Archetype have developed a number of different passive house typologies across a number of different sectors, from archives to office buildings, cultural buildings, other cultural buildings. But our main specialty has been in school, so primary, secondary and nursery school design over the last few years, as well as housing. And we're involved in some of the bigger multi-residential housing developments, the very first ones that have happened in the UK. So I look at us as the kind of grandparents of passive house in the UK, and there's a lot of great practices out there now also applying passive house to their projects. And a really important strand for us is looking at post-occupancy evaluation or building performance evaluation. So revisiting those buildings, learning lessons from our own design or user flaws in terms of what the older schools, like Wolfgang was alluding to earlier, you know, passive house and school design has been around for about 20 years now. It's very climate specific. What lessons learned do we have that we bring forward in our new designs, and glazing strategies are a bigger part of that, for example, and shading. I've just been looking at the chat. So that side of things really informs our design as well as a part of our kind of design ethos. So I just want to kind of summarize and come back to kind of pedagogy, and I suppose why we're here and why some people might be here from the audience on, you know, education, and touching on what Ken said in the introduction. You know, what we're talking about is and I've just been blessed enough to have a baby in the last 12 months myself. So I'm currently on maternity leave talking to you today, but I feel this is such an important subject personally, as well as from a global perspective, about what, you know, the future generation deserve. And you know, we all deserve to be able to learn in a really comfortable space, a space that supports good health, teaching spaces that enhance study. So, you know, a really interesting anecdote I had from a head teacher was around how a passive house school doesn't disrupt the teacher from teaching. And I thought that was quite an interesting analogy, and we'll come back to that later. A safe place to learn and play, of course, an inspiring environment. So, you know, the Greta Thunbergs and the new generation, this generation of students that are so anxious about the climate and what's happening, you know, to be able to be in a school that's actually proactive about dealing with that is really impactful, or a third level institution, as Barry's just brought us through, is really important. And it's going to be more important for those generations than maybe ours. A school that supports progression. So we have a lot of evidence about school student attainment improving through BISRIA surveys in the UK, demonstrating that passive house gives a kind of calm, ordered backdrop to an education process. And just with that as an overview, and there the pedagogical requirements, you know, from any public or private sector, they're trying to develop in the education realm at the moment. But there's a number of challenges, environmental design challenges in schools, and there's been an endemic challenge in the UK, and there still is as we speak. And I'm sure it's the same in America. And I think this screen, this slide, sorry, demonstrates, you know, the complexity of what we have to deal with. We have very variable occupancy. We often have schools in very high density areas where there's a lot of outside pollution, noise, maybe lack of outdoor space. We have increased overheating risk. So there's been some chat in the chat about climate file scenarios. You know, looking at future climates is really important to us. And we will model 2050. 2050 is almost irrelevant now. We're looking at 2080 scenarios and trying to assess how safe those buildings are in that climate scenario, again, which is just, you know, a predicted scenario. I think we're going to be a lot more humid than we think we are going to be in the UK. Indoor pollution, we have ventilation as a result, that's complicated as a result of the occupancy being variable. And of course, then the energy use of schools and the variability, especially in secondary schools, of the different faculties, the different learning facilities that we have, and how we're trying to harness the passive house benefit to limit those losses and limit those issues. I've just thrown the slide in here. I'm not going to read it all out, but there's lots of academic evidence and proven evidence of how indoor air quality has a really adverse effect on respiratory health, on student attainment, and damp and other issues in existing schools and in new schools that have been built very poorly create various serious issues for our children. And those children and students will be in school for a great proportion of their early life. So creating a healthy indoor environment is really, really paramount for that. And the UK government have gone some degree in setting out healthier ventilation strategies and requirements for their schools. So Building Bulletin 101 is our ventilation Bible, as it were, for the mainstream schools. But there has been quite a lot of competing tension in that, because creating a lot of systems and technology to create such good indoor air quality also becomes quite a high energy consumption strategy. And Passive House, I believe, and we can see evidence of, reduces that high energy consumption scenario, as well as giving you really, really good indoor air quality. So I'm here to speak about Passive House. You've heard from Barry about how well it's performing in terms of indoor air quality and energy consumption already. But I think indoor air quality and the health and comfort benefits of that is what we look to as how we sell and how we develop Passive House in the UK now. So it is about the energy and the climate emergency and the energy reduction. And we saw the great 88% savings there in our campus from Barry. But actually the immediate comfort and air quality benefits in our increasingly polluted external environment is something really impactful. And this is a school we did post-occupancy evaluation of, not one of our buildings, and an award-winning school in Scotland. And this is a typical week that school had in February, so a winter condition for the UK, where we looked at a number of classrooms and the CO2 concentration in those classrooms. You can see that by the time we get to kind of 1 o'clock in the day, that we had levels of CO2 reaching, nearly getting close to the World Health Organization limit of 5,000 parts per million, where we start seeing CO2 levels creating harm for those occupants. And again, this was a winter time, windows weren't being opened, it was a naturally ventilated school, and it was a cold and windy week. So there was a number of things that played into this. And I'm sure alongside this, in parallel, not showing you here today, but there's probably an overheating issue in those classrooms as well, with windows that were unable to be opened. So really kind of shocking statistics from a school that was finished in 2017. So a school that was, not finished 20 years ago, but we would regard it as a new school. And just to look at a couple of graphs here, where we have our own study of a 1970s conventional naturally ventilated school on this graph, a typical week, winter, autumn and summer, the three colors. And we can see that in the working day, again, we have very variable CO2 levels and very variable parts per million levels. And we can see that the red line and the red dotted line are showing the UK kind of limiting criteria for CO2 between 1,000 and 1,500 parts per million. The latest legislation requires us in schools to be below 1,000. So again, we've seen Barry's example of being around 500 parts per million in Earn campus. Passive House is more than capable of achieving this. And we can see the equivalent study for the same week in our Passive House school. This is one of our very first Passive House schools I'm showing the example of here. We're well down at 1,200 as an average parts per million from a school that was designed and delivered 14 years ago. So quite impactful Passive House on student attainment as well. You can see the quote from the head teacher here as well. And a lot about what indoor air quality and Passive House is about is really reframing how we look at ventilation. So when we came to Scotland, the generic approach by services engineers for ventilation was natural ventilation first, and let's extract our toilets and our kitchens on a separate extract ventilation system. And we feel natural ventilation on its own simply does not work in buildings. Natural ventilation in a mixed mode sense and complementing mechanical ventilation, we feel is fine. But when we're looking at high performance buildings, we really need to be looking at a more intelligent way of ventilating those spaces. And a really important part of that is looking at what we call the cascade ventilation approach, which we're able to employ in a lot of school design, or you might know it as displacement ventilation. So where the air essentially follows the students around the building. And I can come back to that more in the questions, but it's also a cost saving in terms of looking at ducting and centralizing mechanical ventilation distribution. And being able to explain that and making sure that our occupants understand that is really important. So that backdrop of internal indoor air quality and what Passive House, has meant to us as a practice, how has that affected us in Scotland? And I just want to refer to a few Passive House Trust slides here around the wider climate policy ambitions that's in Scotland. And of course, Scotland have just had some hiccups in terms of their politics recently. So I'm very hopeful, and we have general elections in the UK in July, and I'm very I suppose nervous that some of this will be derailed, but I'm really hopeful that what Scottish Parliament has committed to is a Scottish Passive House equivalent within 2 years to introduce that as a minimum environmental standard for housing. So I'm here to talk about schools, but I just want to give you the context here, courtesy of the Passive House Trust, that we are looking at and very close to legislating a Passive House equivalent in housing in the UK, which has had several endorsements politically, and this is an MP that's still in government. We have had, unfortunately, a change of energy minister in Scotland, but we're hoping that this legislation is already in front of the different cabinets and has been put forward already as a bill, and will hopefully find its way as a legislative solution. And in terms of just a summary here, before I go into the slide, I don't want to go into the slide in detail, but we all end up paying the bill in relation to housing, as well as the non-domestic sector, so the public sector of schools and education buildings, when new homes unnecessarily add to the cost of electricity grid. And we have this huge issue, which I'm sure is the same across the water, about the capacity of the grid. And as we're adding all of these all-electric buildings, which may be zero carbon and may be using green electricity and all of that other good stuff that we always hear about, but the energy demand is still very high, and that grid just isn't capable of it. And the Passive House Trust has done several studies to demonstrate that Passive House could save the UK over 20 billion in that energy infrastructure upgrade, or that energy infrastructure investment that might be needed. So, we're talking about school design here and very local. Here's an example of a Passive House school, but ultimately we're looking at the overall grid and the demand. And as we heard at the keynote speech from the Innsbruck Passive House conference recently, if we could just design all new builds to Passive House, maybe we would have the IPCC climate report. We would have a really fair chance at reducing those average temperatures going up over the next couple of years that are already going up. So back to Scotland, non-domestic schools. That was just a little bit of an interlude into the housing context, which is quite exciting. It's a little bit ahead in terms of being a national legislative requirement. But I just want to talk to you a little bit about the Scottish Futures Trust and their funding programme for schools. So the Scottish Futures Trust are the investment or infrastructure vehicle for investment for Scottish Government, and provides essentially funding, guidance, skills and resources for developing all public sector buildings across several public sector organisations, and in particular the learning estate, so the educational estate. And I'm going to speak a little bit about the Learning Estate Investment Programme, or the LEAP programme, that's been around since 2019, and the context of why that has come about in terms of our education system. So since 2009, the Scottish Futures Trust has intermittently issued lessons learned documents across the learnings from all of the completed schools within the different eras. So if we think about 2009, we're we're 14, 15 years from 2009 now. And the conclusion was that nothing had been learned. No lessons had been learned. Schools were still getting designed like they were in 2005. And there was a really disappointing performance of new schools. So in 2018, Archetype, as part of that SFT learning, undertook a post-occupancy evaluation study of 3 of the top 5 most expensive schools to run operationally in Edinburgh. And we essentially validated their 13 or 14 years of research, which was that there were so many lessons learned that still weren't being applied to schools. We also had some tragedies in Scotland where we had cavity walls failing. There was a 14-year-old girl who sadly died from a wall collapsing on her. And this was all linked back to terribly poor quality of construction, terribly poor expenditure of public tax money. It's the public purse that this is all coming out of. And lots of recommendations that went into improving quality and enhancing the quality. So interestingly, Passive House has come into Scotland from that perspective on enhancing quality of building as well as addressing the climate emergency. So the Scottish Futures Trust, without really referring to Passive House, because they can't just refer to one methodology, set out a outcomes-based delivery program. So in order for you to get funding, you must the building must perform and achieve certain targets, not just energy targets, but all sorts of other targets as well, for 25 years of that initial building life. And the really important thing to us was that it set an energy target for a particular core hour period of the day. There was an indoor air quality target, and there was other elements like enhanced in building information modeling. They incorporated that we needed to have post-occupancy evaluation or building performance evaluation. And actually, the latest wave of funding also requires us to look at embodied carbon. You can see there's the energy banding there at the side, the final energy demand bands. You can get 100% of your funding if you're very, very close or at Passive House levels of energy consumption. And if you're over 131 kilowatt hours per metre square per annum, you're not going to get any funding. So as you can imagine, the local authorities in Scotland absolutely all threw their toys out of the pram. This was back in 2019. All the finance directors of these local authorities are extremely concerned that their funding and capital was going to be limited because the buildings actually had to perform. But the whole industry is rallied round, and at the moment, Archetype are developing 8 plus schools to the Passive House standard in Scotland. My understanding is that there's lots of other great consultants out there also developing. So we're looking at over 30 schools. The biggest educational campus, I think, in the world, Dunfermline Learning Campus, is also being developed by another team in Scotland at the moment. And what's happened with the industry is they've really embraced it and taken the legislation and this requirement for outcomes-based funding for schools forward, and clients have just embraced the fact that Passive House has been around for 30 plus years. It's a proven performance standard. Therefore, if they're going to go into contract to deliver these schools to get these particular results, Passive House is actually the only rodeo out there that's proven to be able to do that over a long period of time. So our example that I want to show you is the first Passive House primary school in Scotland that I was involved in delivering as part of our development as a practice in Scotland. This is just about 1 hour north of Edinburgh, for those who are familiar with the UK. And it's a 2-stream, 500 pupil primary school. It was the amalgamation of 2 local schools onto one site. Excuse me. So the actual premise of the project in the first place about consolidating and bringing uses and intensifying the use of the building was sustainable in its ethos from the get-go. And it has a dedicated special needs area for students, as well as a nursery and facilities that can be leased out to the community. It was delivered in a public-private partnership called Hubby Central with Perth Kinross Council. The floor area is around 4,300 metres squared. The project value was around 20 million. Now, this project was procured just before and actually during COVID, but just before the Ukraine war sent inflation and material prices skyrocketing in Europe. And the contractor has reported back that the over budget spend on that 20 million approximate value is about 2%. So given all the volatility, given they went into contract on prices before the Ukraine war, they were able to hang on to that budget really, really well, and we're still able to deliver a high value, high quality school that was within the median range. So I think close to what Barry's mentioned, I think we're around £3,500 per metre squared at that time for that school. And yeah, we also, this school was the first Passive House steel frame school we've done. So again, I could do a whole presentation on what I really think about steel frame and embodied carbon, but that's for another day. So the site start for this project was November 2021. Practical completion was just June last year, and we're just about completing the first year of post-occupancy evaluation. The brief was very aspirational around building occupants, the health and well-being, the pedagogy of both schools coming together. They both came from very different kind of social contexts, future flexibility. So there's a variety of open plan and closed plan classrooms. And there was a focus on locally sourced materials as well. And the business as usual approach from the supply chain is what we ended up being able to work with. These are just some 3D images, and we'll see the completed images shortly, where there was this idea of a learning street in the middle of the building with a series of open plan classrooms and closed planned but visually accessible classrooms off it, where children came to the centre and dispersed into different learning areas. And there was a variety of different sizes of teaching space as well. And just that drop ceiling on the right-hand side that you see running down the corridor, that's where all of our MBHR and services for electrics, etc., all ran through the building. And I'll show you a diagram on that in a little while. How this project was different was that we had a lot of early stage design team work. So the client ACR, the ACR are like the client requirements or the employer's requirements on the project. I'm not quite sure what you would call that in America, but you know, the client's proposals for what they wanted. And they're very, very detailed brief proposals. They were developed alongside us because we developed them and evolved them with the client very collaboratively to incorporate Passive House, because of course none of their client documents ever before incorporated requirements for Passive House. The contractor came on board very early, so the RIBA, the Royal Institute of British Architects, RIBA Stage 2, the contractor was appointed. Some people love and hate that, you know, like having the contractor involved too early means they dilute the quality of the design. I would disagree, especially with something like Passive House in the contract. You're able to uphold a lot of areas in relation to quality. So there was cost certainty built in as much as was reasonable ahead of the 2020 and 2021 time frame. And of course, this building actually got designed all the way through COVID completely remotely because we were all working at home. So that was even more remarkable when we actually got to site that the building was designed in that way. There was enhanced clash detection and coordination at each RIBA stage as well. And Archetype were the Passive House designer as well as the architect. So we wore both hats, which I would argue is a great advantage when you're working in inexperienced design teams. So there's an existing school on the site that faced east and west, and the ideal solution would be just plop a building beside it, but actually we were able to reframe and look at demolishing the existing southern nursery to allow for a replacement and replacement of the building to be north-south, to be a bit more optimal for Passive House, but also to create a future planning aspiration to create a better sense of place to the south of that building. There's kind of some commercial units and housing, and it's a suburban area. So this was to kind of create a sense of place, or genius loci, as I would have learned in university, to for a future new space in that area. The glazing, you can see the glazing ratios on the top there. We had quite a lot of glazing to the north, of course. We had classrooms to the north and to the south, but you can see that east and west, we minimized them quite a bit in terms of reducing our shading requirement. And this is just an overview of the plan. I won't go into huge detail on this, but we've essentially tried to locate the higher elements of the building, the hall to the north of the site, the nursery and the single-story elements to the south and the ASN, and try and keep the main teaching spine in the middle. And again, the pedagogy wasn't affected. So the client wanted very mixed use teaching spaces, open plan and closed plan. And some of these classrooms can open up into double classrooms and open up into that teaching street. And there's lots of flexibility in the plan. Just a little bit in terms of services. So to reduce the services demand on the building, we went with instantaneous hot water heaters. Again, I could do a whole hour on that, but I won't today because it's fascinating, actually, hot water design. As an architect, I know that's strange that I'm saying that, but it really is. If you really want to reduce energy in your building, you should really be looking at what you're doing with your hot water. The air handling units, the MBHRs, there was several of them through the building, and actually through the design and now the occupation of the building, we would argue that there was a whole MBHR in there, a whole extra cost to the client that could have actually been omitted if there was a bit more confidence in the way we wanted to design the ventilation system. But we were dealing with an engineer who had never developed Passive House before, and they were actually quite nervous of what our proposals were. And we said, well, look, it'll come out in the building performance evaluation, and it very much has, and we can talk about that again at the end. So in terms of the final energy demand figures, we needed to be below between 67 and 83. So the building at RIBA stage 4, so just before the site stage starts, was 62 kilowatt hours per meter square per year. And there's a little bit of nuance about whether we include the heat pump, the renewable energy of the heat pump. So we always presented both so that everybody was very clear on the figures. And out of the back of Riverside, I was the lead author on a paper by the Passive House Trust in relation to steel in passive house construction. Excuse me. So this is a technical proposition paper based on Riverside, but also a number of other steel frame projects that were going on in the UK at the time. And it's just essentially a designer stopgap, as well as just some advice from certifiers and contractors about how they found steel frame construction. Because I can't go into it in too much detail here, but there's a number of challenges with steel frame construction, particularly when we're looking at a warm or blended steel frame approach here. So just the diagram showing you the primary steel zone plus an overclad zone. Ideally, we want to avoid insulating in the primary zone, but because of where we were in Scotland and the U values that we needed and the form factor requirements that we had, we ended up needing a 0.13 U value in the walls, and we had to look at insulating in that area. And again, it's great, you can draw these things, but if the builder can't build them to a high level of quality, we were going to have trouble when it comes to passive house quality assurance sign off. So again, it was all about site and trying to engage house site up to their game in relation to delivery and quality. So this is just an overview of how the building was developing at the time. The red membrane is the air tightness layer on top of the cement board that encloses the steel frame. And there's a 180 mil of mineral wool that goes on the outside of that as well. And we went with kind of a light coloured zinc roof also. So again, without going into construction, some of the changes on the project to make the project actually successful was around those keywords that we all talk about in contract: collaboration and communication. So we set up a really, really robust kind of chain of command around how the passive house designer and the architect, i.e. us, liaised with the main contractor and subcontractor. That quite regularly ended up being, Teams calls. The passive house champion would go out and talk about an issue on site, and we'd be on the end of the phone almost daily. We didn't just wait till our 2 weeks were up to go and visit site and kind of not really engage with the site. We were very getting our hands dirty on site. And we developed a load of posters, almost like the health and safety posters, to really make everybody aware on site they were on a passive house site and what that meant, and tried to kind of evoke that sense of pride in the contractors. And the subcontractors actually on this project and on another project in Scotland, it was actually tracked that their mental health and well-being was said to have improved in a particular survey that one big contracting firm did, from actually doing a really good job and from being asked to do a really good job, rather than just the business as usual, bad quality, shoddy workmanship approach, which was really compelling, really powerful. We did a number of toolbox talks to demonstrate. Again, this was actually in COVID period where everyone had to sit, 1,000,000 meters apart, about good workmanship and how to avoid quality issues, as well as getting value for money for the client out of insulation and materials well installed. Regular site checks happened. So we used a corner of the building as a kind of sample area. So we were always called out, or we were got photographs sent to us to verify the quality of construction on a particular corner of the building before the contractor moved around the rest of the building. So they were really collaborative with us. And I understood that it took them 3 goes to get the ground insulation correct with their subcontractor. And the minute they did, and everyone was happy with it, they flew up, they flew around and got the install happening really quickly. So they were able to work with their supply chain really robustly. And we had a number of different technologies on site: a robotic dog, it helped with clash detection, it enhanced in building information modeling, digital twins. So that was all quite new for the project as well. But really helped enhance the kind of the delivery of the project. So just a couple of images of the completion before I just move on to a bit of feedback from the post-occupancy. So again, this is an image from earlier. I think we were really able to mostly hang on to the ethos of those lovely internal spaces with the mineral wool and the lovely open plan nature and transparent, accessible nature of the building. So even though the building had gone through a VE process, we really try to hang on to those quality aspects. This is just a view of the south elevation. So again, we allowed the roof to extend and did various modelling with the engineers to ensure that G values and shading on that side of the building were going to be acceptable. And you can see that we have some vertical louvers built into the glazing facades, so we can have secure night and evening ventilation, which was interesting anecdote when the building got occupied. we had the teachers leaving the windows open on the inside to allow that lovely ventilation in the summer months, but the cleaners were coming along later on and closing them. So for the first few weeks when the building opened last June, the building was overheating a little bit because there was a confusion between the governance of who was opening and closing windows, just for that night purge ventilation. So obviously not during the day. But yeah, it's just really interesting how you really have to engage the people and the users of the building to use it well. Just an image from the nursery. Again, some of those top roof lights, and again, the little bit of south shading, as well as the external covered play for the nursery on the outside. I just want to focus a little bit on the building performance evaluation, because I think the most important part of any building, just for me as an architect, is that actually when you walk away, when it's completed, is that it actually works, that people are actually happy in it. And, you know, Barry referred to this earlier as well. So we've just got to the end of completing our first 12 months of monitoring on the building, and we'll actually continue on monitoring for a little bit longer just to get back into the September time and get over the summer this year. And those are funding requirements. So we have to monitor, the client has to monitor and has to produce reports to be able to get 25% of their capital funding for this project is related to the energy performance and that post-occupancy information. So the qualitative feedback has been extremely positive from staff, from students, from visitors. And there's just a couple of quotes there, you know, an oasis of learning. One of the students said it's like a puddle of warmth. You know, they really loved their school. They learned all about Passive House before they moved in, and they kind of reflected on it then when they moved in. You know, you're talking about children that are under 12, which is amazing. Coming back to some harder estimates here. So just a recall on our pre-construction estimates on the final energy demand, so that energy target we needed for the funding. And this is showing you where we are after the 12 months. So we're just coming just under what we predicted at design. And again, for some crazy reason in our industry, that's still a miracle to come in under what you predicted before everyone went to site. So it's just, I'm so happy every time I see it, but this is just brilliant to have that verified information. And this is just a comparison against some of the other benchmarks. So CIBSE, the Chartered Institute of Building Services Engineers in the UK, has several different benchmarks for buildings. And again, the blue is showing kind of gas, and electric is the orange buildings. And obviously we're looking at all electric buildings in Europe going forward. And we can see where the LEAP, the learning estate target is versus Passive House versus Riverside, the school, which is phenomenal. A huge topic of debate for us in Scotland was around small power and appliance use and internal gains in the building. So we actually had a huge amount of monitoring, again, as part of the funding requirement, where we're able to extrapolate out how much percentage each kind of different area. You know, we're not talking about fabric here or ventilation. We're looking at heating, kitchen, small power, the sprinkler. And it's really interesting, you know, how much energy we're finding. You know, the kitchen we always know is a big energy guzzler. Small power and appliances is probably a little bit bigger than we'd still like. Equally, I'm saying that and I'm being critical. We're currently 20% less on all of that than what we actually predicted in the Passive House software, the PHPP software, and we're coming well under the compliance target. So, you know, again, it's subject to a bit more further evaluation, but we can, you know, it's been great to be able to report this back. And we can see the heating and hot water are very, very small you know, energy consumers in the building as a result of Passive House. And of course, kitchen with all of the catering requirements for doing hot food and hot lunches. And there's definitely more improvement there where we can. So just to explain these graphs, so I know they're a little bit graph heavy and we're coming to the end of my presentation now, so bear with me. This is the CO2 summer concentration. And if we just look out for the grey dot, we can see that similar to Barry's, we're well down below the requirements here. If you think about the very first slide I talked about was the ventilation requirements set by UK government. We can see that the average value for ventilation is well below the 1,000 parts per million target that we have. Now, the yellow bars show the range that CO2 is over the year or over that time in the summer. So there might be a very, very small percentage of time that it is close to 1,000 or over, but the average is the grey dot. So we're looking at between 490 to 615 parts per million. Very similar then in the winter time. And just two abnormalities, not abnormalities, but, you know, the nurture room was quite high in terms of CO2, but the hall was quite low. And if you remember me saying we thought we could actually get rid of an MBHR, the hall had its own dedicated MBHR, which we believed wasn't necessary. We could have used a different ventilation strategy there and saved the client even more money. So again, that evidence is coming out in this post-occupancy information. And then this is just a graph that's kind of hot off the press for us in the office on the annual average temperature for a day. And we can see that all of the temperatures, very similar to Barry's, are well around the 20 degrees Celsius. The kitchen is a slightly higher because for the first few months, the kitchen, between user confusion and some appliances that just weren't kind of automatically turning off, and there was a higher temperature experienced in the kitchen over the summer months last year. But that's all settled down as part of our post-occupancy collaboration with the client. And again, it's just really interesting, like Barry's presentation, to be able to see the impact on each room. And you can see that we're very, very far away from the 25 degrees. And we had some really high temperatures in Scotland last September, October and June. So the building was properly tested. And then finally, I just want to show you a bit of qualitative feedback from the head teacher, which I think summarizes the project really nicely. So we go through all that hard data and we go through all that heartache and excitement to deliver these buildings on site. And really the ultimate joy and reward is that, you know, people are happy in the building, happy to learn, happy to work. And yeah, that the longevity of that building hopefully is a really great community asset going forward. So thank you.
I want to start, as Wolfgang comes in here, with just, you know, it's so impressive, and to see these buildings and see the work to get to doing the building initially, and then the movement that's being created out of these buildings. And it's really like the scale change that we need to see happening. And I'm kind of starting from a high level. Emery, maybe you first, and then Barry. You know, it seems like in some of these cases there are critical advocates, and I know both you, Emery, and Barry have been critical advocates for Passive House. And we saw the member of parliament who's identified as a political advocate, and others. And I'm wondering, to get this critical mass of activity in school construction, were there certain steps that you see that you did that you can relate here, and what kind of pushback? Obviously you won some arguments and others, and had other allies that were helping you along the way, but what was the pushback, and what were there breaking points where you were like on your way?
You want to go first, Barry, or?
Yeah, well,
Barry, go.
The first thing that would come at me, Amory and Ken, to answer your question, is that a wee bit for us in Northern Ireland, it was a little bit by accident more than it was design, truthfully. But what I found along the way with this all was that there was great people everywhere. And if you consider the island of Ireland, you have Tomás O'Leary across the water, and in Northern Ireland, you know, generally as well, we have the UK Passive House Trust. And some of the literature that was developed early was very, very helpful. And then what happened with us was we started to deliver the Passive House course, and fortunately as well, that was fully funded. And the key junction in the road seemed to be, you know, our college were brave enough to make the decision to go for Passive House internally, and then all that was in train. And then I think what really happened for to be the springboard for all these buildings that have happened is it's actually an upshot of COVID. It was that all this funding was free, and then we were delivering it. And then we had really strong people that we were able to get in for guest lectures. And in addition to that, the UK Passive House Trust had this great reference library of materials that we were able to signpost people to. So we sort of covered all bases where we were saying something, and then we got in expert people who had already done it with other examples from around the place. And then we were able to signpost people to a reference library that wasn't written by us, but was written by other people. And I think that's my best sort of slanted answer on that. But it was more by accident than it was design, I think.
Fair enough. We like good accidents.
When it came to Scotland, I think the fact that there was so many building failures, so building quality failures over the previous decades, when clients heard about Passive House and saw that there was this kind of quality assurance process through design and construction built in, and the presence of the certifiers, this third party person that's kind of verifying things, it became, I know, it sounds like a very aggressive word, but it became a way of them weaponizing their contracts to ensure that they would get the quality, because they were naming, committing to a standard. And of course, the main pushback initially was that, well, we went into the Ukraine war, inflation went up to 10% plus on projects. We had a £70 million project, and 17 million of that was contractor risk and inflation at one point, which was astronomical compared to when the project was procured. So one could argue that actually Passive House wasn't the issue with a lot of the cost fluctuation around that time, because that's the typical thing that's thrown back at you. But actually there was other unfortunate kind of global events affecting that. And actually, interestingly, the tier one contractors in Scotland were more embracing of Passive House as a strategy, because they saw, here's a methodology that actually we can contractually work with as well. We can get upskilled, we can get trained up, we can also kind of get involved in the right way. That was more of an incentive than they were more incentivized than the design teams and architects and engineers initially, who were quite resistant, to the kind of change in status quo. So I really have to applaud, like, the clients, really, the different local authorities, as well as the Scottish Futures Trust, who of course could never put in writing that they're looking at a Passive House level of build. But they came and visited a lot of our projects and other Passive House projects and other non-Passive House projects that had a very low energy demand, to establish those energy bandings. And we were part of that in terms of like what the cost analysis was for that as well. So, and then in parallel to the non-domestic sector doing that, there's a development of the net zero public sector building standard, which also was looking at kind of Passive House and quality driven methodologies to deliver energy. And interestingly, the English UK net zero passive house standard, or passive public sector standard, net zero public sector standard, versus the Scottish one, is a lot more offset based, and the Scottish one's a little bit more based on fabric first. So it's quite interesting how it's just been influencing things and influencing policy, as well as obviously the housing policy. And again, I think there's this idea about investing to save. So yes, we have lots of reports from Passive House Trust about, there's been 4 or 5% on average additional cost on buildings. But I would argue, what has the cost of anything been in the last few years? I mean, we had intumescent paint going up 100%. We had the tonnage of steel since 2020, January 2020 versus 2023, went up 80%. So steel frame was looked at as the low cost construction option here, but ultimately by the time it gets procured and it goes through its whole process, was it really? So cost is always the big myth that everyone hangs their concerns on about Passive House. But I think the quality agenda in Scotland, the tragedies that happened, the building failures that happened, really drove the change philosophy. And there's lots of projects that aren't going to quite Passive House, but they've adopted much of the methodology. And whilst I wouldn't agree with just adopting bits and bobs as you like, it's changed the industry, because 5 years ago nobody was looking at that.
Right. Changes the whole conversation, right?
Yeah.
And what the expectations are for the buildings. It's too bad it takes tragedy sometimes to make progress. So often that's where our codes come from. In the States, where we have this issue of inertia and business as usual, and very hard to break through. Great. Wolfgang, I'm curious, you outlined a number of early technical issues that you saw as needing to be dealt with to put schools forward on a strong footing. And as things have developed, what do you see as further, emergent issues, if you will, around educational buildings, as the uses are more complicated, the demands are greater, and some of the technical issues? And I'll combine it with, I know there was a comment on the BMS system. and your response in the chat about there needing to be work on that. And I'm curious about, as well as I want to fold in maybe, and we'll come around to the whole issue of hot water in the school context. And it's a little counterintuitive, I think, for folks to hear Anne-Marie say that the point source heating, instantaneous heating is successful approach. So Wolfgang, if you could dive in a little bit more on some of those.
Yes, I mentioned all those issues mainly to illustrate the level of uncertainty that prevailed in the beginning. So as soon as a systematic approach had been taken to collect and study all these phenomena, it all more or less disappeared. It became pretty clear what the design task is with a school, how it differs from normal buildings or residential buildings that were normal to that time, and where it is also very similar. So effectively, the fabric, the airtightness, thermal bridging, everything is just standard procedure in terms of passive house. There's nothing very special to schools. Few issues that arise from specifics of large structures, higher loads, that sort of thing. But mainly dealing with this fluctuating nature of usage and operation of different systems is pretty straightforward and can be handled easily. So it turned out that passive house and educational buildings is really, really a good match. I think this has been illustrated very well by the other presentations as well, with air quality and indoor environment in general. Relating to hot water usage, hot water is often a discussed topic, or has been a discussed topic, but if you make a closer analysis, then normally hot water use is very limited in schools if you treat any kitchens as a separate entity. So, but for the school as such, very little hot water is used, only intermittently. So I think an instantaneous electric water heater is really, in many instances, an adequate solution. It's also very cheap to procure, and it needs no energy while it doesn't do anything. So otherwise, much of the domestic hot water energy use is just covering system losses from the storage cylinders, from the pipes and circulation runs. Even in a domestic context where relatively high amounts of hot water are being used, this is about half the energy you spend on the hot water system. So avoiding this really makes a lot of sense in most non-residential buildings. It might be a different case for a kitchen or a cafeteria part, but there you have a detailed design for that bit anyways, and maybe design a separate hot water system for that. Now the third aspect you raised escapes me. Yep.
BMS or other.
Yeah, the BMS. Oh, yes. Well, the BMS.
The kitchen itself was a huge load, right?
Yeah, the BMS, to stick with that for a second, it's not only in Scotland but also in our monitoring that the BMS plant as a whole, the automation of the building, is a large contributor to energy demand, electric energy demand. Not the least because of the fact that it is on 24/7. So since the school is not on 24/7, it could make a lot of sense to design the system such that much of all this can be shut down overnight. But also, if you look closer at all those drives and power adapters that are used, and it reveals that much isn't up to today's standards in terms of energy efficiency. We have rules for the efficiency of power adapters when it comes to mobile phones and chargers and everything, but in the automation industry, nobody asks questions. And so the cheapest stuff is installed So it is very clear that large advances can be made easily if this point comes on the agenda. Yeah, that's for the energy use of the BMS system, and the automation industry has a tendency to advertise their systems and technology as a means to save energy, which might be true if you equip a totally crappy building with a thermostat. But when it comes to a passive house, then this is no longer true. There's nothing to save anymore. It's just a functional necessity to get the building running. And we must focus on getting this done with an adequate amount of electrical energy spent on that.
That's a great point. The equipment energy usage. I know in the States, our TV cable boxes, they're much better today, but you could basically heat your home, your passive house home with just the cable box. It was throwing off
Similar case, yeah.
For the television. Anne-Marie, anything to add on the hot water? I know a sentence or two.
Yeah, I completely agree with Wolfgang. I think we're like just going through a process now because we're so metered that we're just going to go into all the minutiae on this project as well, try to find out how we can improve it. But yeah, the hot water was quite a story on this one where, yeah, we had, 5-liter sinks with 30-liter instantaneous hot water heaters specified initially. And if you think about it, like by the time you fill the sink of 5 liters of water, a 6-year-old isn't going to stand there and fill the sink with 5 liters of hot water. Like they don't even stay long enough to wash their hands. So we kind of apply this common sense approach because obviously everyone has their responsibilities legally and someone doesn't want to under design anything, but the things were so being grossly over designed that even a 7 or 10-liter instantaneous hot water heater for a 5-liter sink is a little bit, depending on the recovery rate. So I got very excited as an architect getting into kind of those details because they made such a difference to the PHPP figures. And we could have even bettered it again. I still think the hot water needed more work, but we're going to bring that with the team into other projects. Now we did for the hot water in the kitchen. We had some water storage and an immersion, so there was a little bit of water storage in the kitchen, but we had started out with water storage in lots more other places. And as Wolfgang said, there's kilometers of hot water pipework in buildings if you don't decentralize it into an instantaneous way. And also then the pipework, so the dead leg ends and making sure that those point of use are really, really close to where, the water heaters are is really important. And something I learned about the recovery rate. So different water heater brands will have very different recovery rates. And obviously the longer the recovery rate is, the more energy it's probably using to kind of generate that recovery. It can be, if it takes longer, it'll use a little bit less energy, but then it depends on the volume that it's trying to heat up. So yeah, I'm not a services expert, but I certainly can ask the right questions now when it comes to hot water design and try and get the right solution with the team. Yeah.
Great. Go to Barry on the two things jump out. The earth tube system was quite massive. And just curious, you mentioned this and couple that with the CHP, and why you thought you wouldn't do it that way again.
Yeah, so the CHP, I talked to it first. The experience has been sort of post-occupancy that, very simply put, if you look at a hotel, a nursing home, a hospital, continuous use, we're not 24/7, nor are we every day of the year. And then if you take a passive house building in terms of its concept, it does not need additional heat. It does not need additional power. Therefore, combined heat and power was a curious sort of situation. But, when you get into again, Anne-Marie's sort of talked to it, I think, as well, around just over design, fear that the passive house standard wasn't going to work, a public building, the way in which, these contracts were devised, this was all what we were competing with on it. The reality of the CHP post completion was click on, click off, click on, click off, starter motor gone, this sort of thing. So that's something I think, as a strategy for the college, we might look to decommission and then maybe get money back on. Thankfully, there was backup arrangements which we were able to go to, and again, we're probably still in the process of working through those. And then your first question, remind me again.
The
Earth tube.
Earth tube.
Yeah, they seem again. This building was pitched as a bit of an exemplar, so there was a little bit of latitude to sort of reach for things like this that were different from the norm. Now, they are in many other projects, so I think they are a little bit different than normal, if I may say so. But so far with them, they're working well. They're static. They don't move. No moving parts. So again, the science of those is well grounded, particularly within the passive house community as well. The one thing I would say around those is, again, considering that, you know, our location in Europe, we're not like the States. We don't have huge swings in terms of temperature. So, you know, you factor that in, you know, it's something that maybe, you know, if it wasn't an exemplar, would you do it? I'm not so sure. But again, it certainly helps me whenever I'm hosting people and there's more to talk about and to point to. It's definitely welcome.
Great, thank you. Wolfgang, reminds me that the swings, you had mentioned early in your slides, I think something about access to thermal mass, and which is not something we typically hear. I think if I remember correctly, associated with passive house, that thermal mass isn't helping so much on the heating side, but on the cooling perhaps. Could you speak a little bit about thermal mass in relation?
Yes. And this is one of the few really important differences between residential passive house buildings and these educational buildings. In residential buildings, thermal mass is really not such a great concern. It is not very important compared to insulation, and you will have some structural mass in any building anyway. So, but in a residential building, the usage pattern is fairly uniform. There are people who have some activity, but it is totally different in a classroom which stays unoccupied during the night, and then a crowd moves in, a massive amount of body heat is introduced in a short time. So it's really, as we have seen in the plot, it's 40 or 50 watts per square meter. That is really a massive amount by passive house standards, and all this heat is released in a short while, which means that even in the wintertime, the room might get warmer than we'd like to have it. And it is beneficial to buffer this heat in the structure for later use, put it by, so to say, and limit the rise in temperature that does happen. So this is why access to some thermal mass is really beneficial in densely populated passive house buildings.
Yeah.
So whether this is a classroom or a meeting room in a administrative building is unimportant, but this dense population is what matters here. It is a bit, to some degree, offset by the high airflow rate you need for so many individuals, but still it's clearly beneficial to have some thermal mass and to have good access to it, which is a bit conflicting with acoustic comfort. And oftentimes, as you might have seen in the slides, this is managed by having a certain zone which contains all the MVHR ducting and installations, and the rest of the classroom can be kept clear, because this ducting drywall thing is also covered in acoustic absorbing material.
Great. Thank you, Wolfgang. One quick round of comments, if I can, to wrap this up. It's been a wonderful first part here. There's been a good amount of discussion. I think it came up in in the presentations, where these buildings are performing as expected and even exceeding expectations, which is fantastic. It's what we want to see and what doing the math is all about and executing. But we still have this conflict, maybe too strong a word, but resistance and difficulty in optimizing the systems, and with traditional engineers, people coming to Passive House for the first time. And we still see within the the performance here that Passive House has a certain conservatism built into it, right? In terms of having some buffer for life, that it doesn't actually have to perform like it perfectly like an airplane to be safe and healthy and have that continuity. So maybe just a little bit here on any advice in bringing in new team members, how you build a team to get to those optimized outcomes and what you see working out there. Anne-Marie, let's start with you.
We have brought and demonstrated, I mean, and Wolfgang's referred to it as well, like we have a wealth of data demonstrating things around energy consumption and power. So in particular, when we look at services, it's such an intrinsic part. I've just went on a bit of a little rant in the chat there about services. Like, it's so important. It's, I put them on a pedestal at the early design stages, and the culture is that they really want to sit back. And to be honest, their fees and their scope limits them, so they are forced to sit back and wait till the architect has done their design, and they might comment, etc., and do the due diligence through that process, but they don't really engage proactively with the design. So as a solution in relation to clients and consultants, bringing them to visit buildings, coming in to tinker around with BMSs, even if they are high energy guzzlers, and that's not perfect yet, but to come in and see the evidence that the building's working gives them confidence then maybe in the architect or in the client that they're able to deliver the low energy building, and they can design these systems that low. I think coming to visit real buildings, and I know that they can be very few and far between, especially across, say, America, the east and west coast, and they're still quite few and far between in the UK as well, but you're usually within a couple of hours instead of kind of a multiple hour experience. That's been the most impactful, and that's, we brought the Scottish Futures Trust, for example, to our buildings, and a couple of different other members of government, etc. And how we got to that position was just, I think, simply knocking on doors, presenting, probably delivering over our just being an architect, kind of really going, we're really believing in this for the better good. We're tramping the pavements, trying to get a bit of publicity and awareness about this. And the other part of it is really believing in the training. So, Barry referred to the kind of funded opportunities there were for training. There is a lot of funding and investment coming through, and ECG goals coming through for developing environmental awareness. And, it can be hard to try and root that out, but I think bringing people to see live examples and then showing them the data, even if it's a very small amount of data, it's very impactful, and can really help bring that change about.
Great, Barry.
So yeah, for me, it's quite interesting. Just taking some notes there and trying to be a wee bit different, because I'd agree with Anne-Marie very strongly. The big thing in communicating all of this and trying to get people over the line, be it building a team for a particular project, or for the likes of ourselves teaching the course, is really to pull out the contrast between what these passive house buildings do and the fact that they do exactly what they say in the tin, but also just again to hold a mirror up to the existing, honest, I try not to use bad language, poor buildings that we have everywhere, and those examples are everywhere. One really geeky habit I have here is when I arrive in a public building, I'll go and take a photograph of the energy display thing, and then do a little bit on the calculator to just see. And again, that's not factored into effect the performance gap, but even looking at that versus a passive house constant like 15 kilowatt hours, the swing is huge. And this is what most people don't do, multiply that by 25 years. If it was a lending period for, this extrapolation then. But one thing that always seems to land with policymakers or department officials and stuff when we have them at the Erin campus is, you say to them, don't make a 25-year mistake. Don't make a 50-year mistake. And that seems to terrify them in terms of, okay, I'm listening. Okay, because as the climate change imperative just gets greater and greater and greater, I think they all know about that. They all know about that landscape. And again, injecting that wee bit of fear seems to, make them sit up. And then the other thing that works for us in the communication of this so far as well is, and in another presentation I have in the Erin campus, is really to just, I think the first 10 slides is, there's Cornell Tech, there's Monash University, there's all these examples all around the world, and it shows that they're not alone, that this is happening. Look at what we've seen from Amory, 8 live projects in Scotland. I mean, why would you not do it? So I think these ways of communicating can be very effective,
Yeah. Great, thank you, Barry. And Wolfgang, maybe if you speak to a little bit, I heard Barry mention performance gap and the idea of, we know every building can't be certified, but the role of certification as a critical quality control measure and the difference between the buildings and closing that and eliminating the performance gap, hitting the numbers.
Yes, I mean, I think it is very much as Anne-Marie has illustrated before, that Passive House is for the first time a clearly defined target of what to achieve in a construction project, a measurable yardstick against which you can compare your numbers. And so quality assurance along the value chain is important for every high quality product. And with a Passive House, this starts with proper education of the design team and proper training for the tradespersons on site, quality assurance measures in site supervision. The airtightness test is not only producing a nice number, but it is also a quality check of the building envelope. Airtightness is also a good indicator of general build quality in many instances. And as the Scottish examples we have seen show so very clearly, is post-occupancy monitoring, particularly in the first year, this performance evaluation and performance optimization. This is really, really important to have to involve designers in this phase, to have them make those systems they designed operate as intended. Is something that makes a huge difference. We find that also in Passive House projects, of course. We get back to the automation questions. So it's not only that these automation systems tend to use more energy than we'd like to, but they also might be programmed to control strategies that are less than ideal, and in some cases even totally inappropriate. So it's of course good to address this in the design phase, and it should be like this, but we should have our checks and balances when the building starts operation, and to check this and verify the controls don't spoil our performance. Just for one example, I mean, the Passive School relies on this intermittent use of MVHR. If for any kind of fault the MVHR stays on 24 hours a day, then of course the space heating energy will rise by a factor of 3 or so. So this is horrendous. And it's a very simple fault to happen. We must have strategies in place to detect that very quickly and mend it. And this also touches to the contracting of what is defined as the service someone is hired for. This must be part of their job to troubleshoot, optimize, and get everything in good shape. And if there's no, if that's not factored in the contract, then everybody just shrugs their shoulders and or ask outrageous prices. So
Yeah.
This monitoring bit and performance optimization is really something I'd always warmly recommend for every non-residential or generally larger building. That makes a lot of sense.
Yeah. Thank you, Wolfgang. Yeah, let's stick first principles first, and the fixed targets really change the dynamics. Thank you, each of you, for presenting today. Anne-Marie, Barry, and Wolfgang, this has been fantastic presentations and conversations.
A little bit of information about the school itself that Naomi may want to talk us through a little bit about a background of the school and how we got started.
Yeah, thanks. Yeah, so Friends School of Portland, I was a founding board member of this school, which was it's a pretty new school, and we had an amazing, remarkable location on an island just off of the city of Portland, accessible by causeway. It was a very sweet spot, and we grew that school for a number of years before we realized that we needed a new location for a variety of reasons. So we had, you know, something like 100 students, and we were shopping around for a new location. And it was kind of an interesting time for me to be this confluence of my two interests. One was this new Friends School. I grew up going to Friends Schools, but in mid-Atlantic states, but I also grew up in Maine before going to boarding school. And I was really excited to have a Friends School being built here. And at the same time, I was gearing up Passive House Maine. And so I had these two sort of sharp interests that had this moment to have this incredible synergy. But I was really aware when I was a board member, and at that point actually chair of the board and chair of the building committee, not to wholly dominate the conversation about what the new campus and buildings should look like. Some of the things that we were considering were access with public transportation and ped and bike access versus kind of country day school feel, something that would be out with its access to nature and sort of growing that kind of nature-based curriculum and identity that really was fairly well established on the island, Mackworth Island. I actually campaigned kind of hard for the in-town campus, but ultimately the nature-based identity prevailed. And so there was this part of, this is the location in the school that Richard has pictured here, was accessible really only by car. And it was pretty much just about a 10-mile drive for anybody to get there. And so as part of penance, partially was a sense that the school itself should function as lightly environmentally, as with a light and environmental impact as possible. Yeah, so the design.
Right. So that was already a little bit of a stretch, I think, for the Board of Trustees to find yourselves a little bit surprised to be occupying a wooded site that you had to drive to.
Yeah.
Which gave us as architects some immediate site challenges to figure out the best orientation and location on a site that I guess became available for the school because the site was challenging. There were protected wetlands, an odd site lot line configuration, topography, and so on. So that automatically limited our options for even where we could put the building realistically. And then the the goal, of course, was really how do we go through the design process while being able to keep the possibility for Passive House alive as much as possible for as long as possible. The school's priority was to open a school. And we need to provide the program simply enough, but also work with a builder and keep our cost estimates in line to still keep Passive House as part of that picture.
Right. I mean, just to clarify, the board did not commit to Passive House at the onset. They're like, well, it seems like a cool idea that Naomi has. Let's like see if we can really pull it off. The highest priority is building the school, as Richard says. And actually they had in their minds collectively a concept of net zero, whatever that meant. And Kaplan Thompson, Richard and Jesse and Phil provided a lot of information for the board to make informed choices about how they were spending their dollars.
So we concentrated on trying to keep the footprint as compact as possible, keep our building costs down.
Finally they get, oh my God.
And
Finally they get this
keep
brochure.
the overall simplicity as much as possible.
Let's just ask people to mute. It's a little distracting, right?
Yes, yeah.
Great.
Thank you. So we settled on something fairly straightforward: central lobby, central corridors running east and west. So we had our classrooms generally facing with a long face towards the exterior. And again, they're competing requirements. Stretching the building out gives us a nice long exterior for windows and connections to the exterior, but it also makes the volume of the building bigger and therefore the footprint bigger and the cost bigger. So trying to balance those things and bring the school board along was always part of the picture. But essentially, we had classrooms that we wanted to provide with as much natural daylight as possible, minimize our electric loads at the same time. And the strategy was to provide as many high-level windows as possible, minimize the view windows, if you like, and balance that desire for wall space in the classrooms. That was an interesting realization as well, that for classrooms, it's not necessarily ideal to have lots of windows because you actually, you want to focus on the internal space, and you really want lots of wall space for furniture and displays and artwork and so on. So again, there's the balancing of competing requirements. Here are a few shots of the typical classrooms that we've, I think we found a nice balance of daylight as well as that internal focus, and particularly by keeping a lot of the windows close to the end walls of the classroom. So there's a lot of secondary lighting with daylight bouncing off adjacent surfaces, the ceiling, the adjacent walls, and so on. A major part of the program was a gathering space that had to be multi-purpose given the nature of the school's program. So a gathering space, but also used for internal sporting activities and performances. So this was really a major part of the program, and one side result of the wooded site that the school had chosen was that there were, in fact, some significant trees, particularly pine trees, which were harvested from the building footprint. And that's what we're looking at here in the interior of the major gathering space. So again, I guess, as Naomi said, for penance, we certainly did our best to do our best working with what we were presented with.
There was a real focus on honoring the land that we were actually using. And yeah, I actually wanted to set the stage for the fact that this is quite a long time ago. Actually, we were having these conversations in like 2012, 2013 as
Right.
the first passive house school in Maine, and the third in the country, but I think the first was not even, didn't really count. I think that I consider this the second in the country. So there was a lot of just in sort of general understanding of what was passive house, what was the what were the advantages, what were the potential increased costs, and it was still so much of an unknown at that point.
Right.
Yeah.
That's just a photo of during construction, but it does show the quality of the light that we were able to produce. But really, getting to this point required a lot of discussions with the school board, and Passive House, I think, provided a really good framework to try out different options for the overall shell construction, the window performance options. We could plug in the air tightness targets that were feasible to strive for, and see what the result was in terms of the expected energy performance. We did this a number of times over a period with the involvement of the contractor as well, Warren Construction, who are fantastic. And I think that gave the board some tangible parameters to work with as we were discussing the various options. And we were well into the design process before it became necessary to really make a decision. Was this project going to go for Passive House or not?
Well, actually, Richard, can I just say briefly about that? Because there were, so the board said, yeah, we're interested, but we're not going to commit, but let's go through the design process, trying not to eliminate the potential. And that actually included in the very, very beginning conversations about where the building was going to be placed on the site in terms of what kind of access to the southern school could have. Additionally, the design team was like a critical decision that the board made. And it was actually a fault step. We made a decision, and then we had to renegotiate that decision. We had to make a shift in our design team in order to get to where the board wanted. And there were a series of moments where we just like checked ourselves, like, what is the window to wall ratio? Are we going to make it? What the height of the roof became an issue in terms of being able to mount our solar panels and the height restrictions in the town.
Correct. The section here does illustrate that. This is you can see the two-story classroom wing with the steep roof, shed roof, designed to respond to the solar orientation and the need to provide a place for solar PVs as far away from the protected trees and wetland, which was to the south. So we pushed the building as far to the north as we could, up to the setbacks, and lifted the roof up as high as we could in that location. And in fact, the local authority were extremely supportive and sympathetic to the goals for, they actually adjusted their height limit for this purpose, which was incredible.
Yeah.
Eventually, we did get to settle on the exterior shell assemblies and the performance targets. And in some ways, that was the easy part of the process. We were careful, I think, to make sure that we used conventional details and materials in order to allow for the widest possible options in terms of contractor, subcontractor, familiarity, try to keep things as simple as possible. But eventually we did come to something of a crossroad as we were selecting our ventilation equipment. And that was a critical component for the ventilation and efficiency that we were able to include in our energy model. And at this point, we needed to decide exactly what were those shell assembly targets and what was the equipment. And it was, in fact, the equipment which triggered that significant discussion where, for cost reasons, we needed to go to equipment that had lower efficiency in terms of the passive house certification, and how are we going to compensate for that? We were early enough in the design process to be able to tweak a few things, and the response was to increase the sub-slab insulation, but we had to make sure we had that in train before the slab prep was happened, of course. So that was the time at the point at which we needed to say, right, is it passive house or not?
Yeah, and I think at that point the board said, we're in, like, all right, we'll do it. We've come this far. It's quite clear that it's not too much extra to put in a wee bit more insulation, and we'll do the full certification. You know, at that point, the board was willing to lead by example and to really put the plaque on the wall and be able to hold themselves to that standard and inspire others. So they said, you go for it.
Yeah. So in the end, I think the discussion and thought about the exterior shell and the windows performance, that was the easy part. Ventilation equipment efficiency, that was an interesting inflection point. And as we went through the certification process, analysis of thermal bridging at critical points like door thresholds, we probably spent more time exploring those details and technical requirements than the exterior insulation and shell details, which was, it's interesting which parts of the process I remember now as being the more challenging aspects. I think in the end, we were extremely pleased with the result. The builder did a fantastic job with the air tightness. I think the site supervisor, Mike Mathis, was he was all over this, and he brought all their subcontractors along, so everybody learned an awful lot through this process. I think actually,
Everybody
it was first time for the whole team, wasn't it?
Yeah.
Yeah.
I don't I know we're coming up on time, Richard. I thought we had a couple more slides and then a summary of from the board's perspective.
This is the last slide I have. So
I would, so I guess I wanted just to sort of close with some thoughts about the how the board was feeling about it all. There was some anxiety when we were moving location away from this truly precious island environment off the island and onto the mainland to this driving place that you had to drive to. And we really budgeted for a drop in enrollment and sort of prepared ourselves for a transition time that was that could be a little trim. And in fact, the enrollment exploded, and we, by virtue of the interest in this new high performance building that was beautifully built. I mean, Friends School had its own reputation on top of that, but absolutely the building and the interest in treating the environment the way we wanted to treat it was absolutely part of the appeal. Additionally, the board itself just felt like and I personally, as the chair, was so grateful to sort of offer to the school in perpetuity this low level utilities cost, very predictable, as part of our budgeting process, which was in Maine anyway, you have the heat line of a budget, which is always this X variable that could, be a teacher's position or not, depending on how severe the winter was. And so to be able to offer the administration the ability to budget wisely and with confidence around that line item was really helpful to them. And we were grateful to have been able to do that. And then further, as a result of this building 10 years ago, like immediately the next year, that same builder built a passive house high school, the first high school in the States. And then immediately after that, I think actually Tim's project in the Montessori school was quite close on the heels of that. Another private school did another wing. And as a result, I think now Maine has a cluster of significant number of academic school buildings from, preschool day schools to university dormitories. And Tim will talk more about that beautiful building up at College of the Atlantic. And we have the biggest dormitory right in Portland, it's Passive House. So there's just loads happening in Maine. And I really do credit Friends School of Portland as being a true inspiration and sort of leadership in offering this path to other schools. And we are just really waiting for public schools to get on. I mean, public university did join, but public grade and elementary schools, I'm looking for that.
So thank you all for having me here today. I'm going to talk generally about our journey through doing Passive House with academic buildings. We kind of had a little bit of a head start in having done a certified Passive House for the University of Chicago, which was technically an academic building, and we did it before we were even really knew what the challenges of an academic program versus a residential program in Passive House certification and energy performance design really would mean in the design process. And so we were a little naive. This was back in 2013 when we designed this building. And a lot of trials and tribulations here, but a lot of great learning potential that allowed us to kind of uncover some of the kind of real core criteria and hurdles that Passive House has when we shift from residential to academic. And I think some of these came up in the first part of the seminar today. And I think it's always really important for us to reiterate that while we do absolutely celebrate all of our institutional clients that do Passive House residential buildings like dorms, they're completely different animals than actual academic programs. And what I'm going to talk about here today is specifically an academic building. I think that's the focus today. And really those hurdles are kind of like numerous, and it is about kind of a total different mindset change and thinking about how these hurdles can become design challenges that are exciting and something new to take on. And, as a designer, as I like to say, it's like, I got into this business because I want a new design challenge. I don't want to have to do the same thing over and over again. And so applying Passive House to a more challenging program is one way to do that. And so we look at high energy use, tight operational budgets, generally low average indoor air quality across our academic sector in the US, especially interior climate directly affecting program outcomes. So kids getting sleepy in class, things like that. Large occupant pool that's very transient. There's often program needs that come with these academic spaces. So they're looking to do something that's sustainable at the same time as they're trying to expand their space needs. Oftentimes we are posed with campus constraints, which means limited options for orientation. Something we love to do in Passive House is like site that building just perfectly to face a certain direction. You can't always do that in a campus setting. And then often we're faced with poor daylighting and views in the traditional spaces and trying to address that. Well, to me, there's opportunities in all of that. Like these have answers that Passive House can provide. And as a designer, you are looking to lean into those. So high energy use means potential cost savings. Tight operational budget means there's an excellent opportunity to show an ROI to those governance groups that are making decisions. Low average indoor air quality, well, we can show we're bringing 100% outdoor fresh air. We're looking at healthier learning. We're looking at improved attendance. We've seen that in some of the schools we've finished. We're looking at performance in the program outcomes. We're looking at modulating and flexible designs that can actually have an effect on that occupant pool, and didactic opportunities for the programs that serve them. So buildings that actually teach their occupants and their physical nature. We're looking at building communities on campus with the way those forms interact with other buildings. We're looking at getting to design unique forms. Sometimes making a Passive House work with those orientation goals sometimes means an exciting new architectural form that we didn't think of before. And the opportunity to introduce biophilic spaces through daylighting and views when you don't have those direct impacts that are typical for conventional buildings. And I like to think about it as these escalating challenges. So we have 3 projects that I'm going to go through quickly today. And the first is like what I'd call it's like the foothills. It's a really simple school, Montessori school, Corner Spring Montessori School right here in Belfast. It's in the town that our office is in. At the time when we designed the school, 3 of us, all 3 partners in our office had kids in the school. And it was a kind of a labor of love on this one, but pretty small, 92 students, 10 staff, pre-K through 6th grade, general academics, no atypical occupancies, no atypical ventilation requirements, and a totally typical calendar year. So it was a really great kind of first step, dip your toe into the waters of what it means to design a Passive House for a school. Shortly after that, we were awarded the Waring School project, their new school building, new academic building on the Waring School campus in Beverly, Mass. Stretched the challenge a little bit. It's a bigger occupancy, so it flexed up to 180 students at max capacity and 20 staff. It was 6th grade through 12th grade. It was still general academics, but it was hosting an all-school meeting every day and an all-school salon every day. So that occupancy would balloon from 60 to 180. That wasn't just kind of this kind of micro flexing. It was literally every day you had a ventilation system that had to flex in that way, but only for that 15 minutes when all those students were gathering together. But still a typical academic calendar. And then lastly, we'll call like this is the Alps or the High Rockies, the College of the Atlantic, and we're talking about higher ed. That's a much more difficult academic program when applying Passive House. So here we were looking at 100 to 250 students and 40 staff. It's a collegiate program, so it's a little bit more dynamic and higher intensity. We're talking about a building that houses humanities, art studios, including painting, drawing, printmaking in a darkroom, labs, botany, geology, chemistry, zoology, a working greenhouse, and a taxidermy studio. It's a trimester with an additional lower occupancy summer semester, so further stratification in that occupancy across the entire year, which led to ventilation variance between 1 and 12 air changes per hour, sometimes at the same time within the building. And it also had lab level refrigeration with negative 80 Celsius freezers. thankfully, we'd done some of that before with that botany lab for the University of Chicago. So pretty wide range here, and this is all within essentially 4 years in our office. We were looking at all 3 of these projects, some of it simultaneously, but trying to always learn from each other along the way and how we would apply Passive House across these. So jumping in, we're just going to start quickly with the Montessori school. We call this project What If Every School because it's the most applicable. It's something that could be applied to any school of general academics, K-8, that had a typical calendar year. And they had some simple project objectives. They were forced to move from a leased space. So they had a deadline, they had to move out, and they had to move into a new building. They had a really tight construction budget because of that. They had been renting for the entire history of their program, and now we're going to invest in a building of their own and own a property. They had a really restrictive operations budget. That is something that was actually our biggest tool in trying to advocate for Passive House in this project, was that if you could take that $8,000 a year you're spending currently heating your building and cooling your building and turn it into additional program opportunities, like how radically would that change your viability going forward? And it turns out quite radically. They were space constrained as well. That's a common theme on every one of these projects, that you're trying to take on something super sustainable at the same time as you're trying to add more space to these programs. They could not afford Passive House certification. They told us at the outset, we tried to show them that as an opportunity, but they needed that PH performance because of that operations budget. So we ran Passive House as a program on it anyway, because we try to take that to every one of our projects. But we knew from the outset that this was not an institution that could afford ever to certify. They had a vocal and engaged school community, an open undeveloped site, and required a simple one-story assembly. So some of the challenges were high, some quite low. The site, they purchased the site near the industrial park in Belfast across Route 1. It was a really nice site, completely undeveloped, really nice woodland in the back. We did a one-directional drive for safety. We had extra site space, this green area for future development. Actually, at this point, there is a future development there. We added a middle school annex later on a couple of years ago. They had options for orienting the building, which was nice. And the site layout provided opportunity for a non-traditional play space in the back, as well as didactic stormwater features that are beyond the scope of Passive House, of course, but something that was quite symbiotic with the design approach. So the program layout is similar to what you'll see that we started to work on throughout our academic work, is that what we learned early on, even with that University of Chicago project, is that when we're looking at high occupancy buildings, and some of this came up in the first part too of this seminar today, is that we're trying to radically kind of flip the way we lay out space, where we're trying to organize spaces for circulation towards that south solar orientation, and the spaces for congregation away from that. And that does two things. One, it helps us balance those potential gains that can push us into an overheating scenario that might not be an issue in residential. The other thing it does is it allows us to use a lot of natural daylight in the classroom spaces without creating program affecting glare problems. So we like north lighting in classroom spaces if we can. It's just better for educational outcomes. And so here you can see we basically had this kind of shielded toddler space. It was the only space kind of close to the entry. 2 primary classrooms of 20 students each, 2 elementary classrooms, also 20 students each, and then this common space along the front. And that added up to the total student body of 92. Plenty of other ancillary spaces throughout the school for staff and break rooms, et cetera. Some common workspaces, breakout spaces you can see here, oriented between the classrooms. And then the solar orientation, again, to kind of make use of solar gain, but in spaces that are transient, so we're not overheating parts of the building that can become problematic and uncomfortable. What that yielded in this particular building, and what we do typically, because a lot of times in our projects we're looking at kind of whole building energy and compared to other national average buildings. So the numbers I'm going to report today are mainly converting everything into site EUI. There's some that we'll look at in more traditional Passive House numbers, but we're always looking against that national average, because although we do, consider passive house the primary paradigm that we're trying to design to, we're cognizant of, the effort to try to get the entire entire sector closer to zero. So we're kind of looking at that kind of asymptote curve down. And so always starting with the national average as high as it is. So for a K-12 building, the current national average is around 75 kB2 per square feet per year in EUI. Passive house target, if I pull out the regional factor for primary energy, is around 19. So we modeled this at 20. We knew they weren't trying to certify, so we didn't go further than that and trying to really dial it in for getting certification. But we were pleased to see a year into use that they were actually running the building substantially lower than that. Before renewables, their measured EUI was at 14.9 kBD per square foot per year. And once they factored in their solar array, they got down all the way to 3.7 kBD per square foot per year in total energy use. It's pretty remarkable for a building that's kind of serving, young kids at this a very small institution. The amount of savings they were to take from that was significant. So that savings was amounting to almost $19,000 per year when we're looking at total energy. And we're also these days looking at everything as kind of holistic emissions too. So when we're going back to our old projects, I like to also consider what its localized impact as a total carbon contribution is, and in this case, in terms of operational emissions only. So a traditional building of this size, this is only a 6,100 square foot building, be about 7 cars a year of carbon emissions. We were able to take that down to about a third of a car per year. So 1,400 kg CO2 per year in operational emissions only. So pretty nice project to start with in kind of general academics, easy test case as far as things go for passive house. And, it ended up being at its cost per square foot, a quite beautiful project too, really successful for them. They've been able to have a wait list and full occupancy since the building was built, which is really exciting. Because it's passive house, we always want to just go through our partners. There's a Kinnear-Sud Windows project, EPS and dense blown cellulose, Renew Air centralized ERV, Daikin air source decentralized heat pumps, and a 16 kW solar array. See that here on the roof. And the challenges got definitely more intense as we got to the Waring School. This is a project that we started in 2018, late 2018. We didn't name it the Bridge because while the project wanted to be passive house, that was stated in their goal, they wanted to be a certified passive house. It had a very constrictive, inaccessible campus that wasn't ADA compliant. They also had a tight budget. They had an established residential scale of campus. It was a campus that had occupied traditionally old suburban houses, and now they were starting to build purpose-built academic buildings. They needed a new beacon for campus. Again, I said certification a must. And they had a vocal, engaged school community and a really restrictive local ecological overlay. So the footprint of the building was incredibly tight. There wasn't really any options for moving the building around or orienting it differently. They also had these space needs that we've seen in all of our projects. As I said, this was an all-school meeting that I noted earlier that we attended in their old space, their old forum space before we built this new school. And literally in the 15 minutes when we were attending this meeting, we saw kids falling asleep because I can't imagine what the CO2 levels were in this room. It did not have centralized ventilation, certainly didn't have an ERV. And this is only for 15 minutes, packing 180 kids into far too small a space. So they, as I'd mentioned, wanted this connection to upper campus as well. What we had said was, well, you could make the most compact form and you would definitely be able to certify it as a passive house, but then you're going to have this long bridge that's going to become a maintenance nightmare for you to try to make it accessible. What if we were to just let the building be the bridge itself? We said that knowing that, that might really shoot us in the foot on passive house. Like if we can't, we're going to definitely increase the envelope by a lot by doing that. But it was the winning concept for them because it unlocked that other kind of healthy community aspect that they really needed to be part of the project, because they needed to stop driving their students that needed to use a universally accessible pathway up to the upper campus every day during school. And so what that meant for us was really trying to think carefully about how that bridge connection could help us, right? So this is actually a view of the second floor of the building. The first floor was that simple volume, but we were able to use that bridge connection to at least get some southern exposure in the circulation spaces to allow a little bit of energy production through solar gain. Again, trying to avoid having that in any of the high occupancy spaces and keep it shielded from the big all-school meeting space, which had become the new beacon back to campus. This actually worked quite well as a strategy. So the bridge ended up costing the project more for sure, but it unlocked an ADA compliant solution for their entire campus by using the building as that mode of transportation, and also improved the performance of the building, even though it increased the amount of envelope. So that was a really kind of enlightening approach. We're lucky it worked, I think, because we'd already sold them on the form. But sometimes these things have a way of working out. Again, you know, comparing the numbers against the same kind of national average of 75 kV2 per square foot per year, same passive house target. We were modeling the primary energy, again, after we're excluding the kind of source factor from that, to about 5.7 kV2 per square foot per year. Its measured performance after a year of verification is a little higher than that, but still well under the threshold of passive house compliance. And they aren't a renewables project. They don't have renewables on this building. So again, still staying in that same mode. When we think about it as a kind of total carbon exercise, Massachusetts, because this building is outside of Boston, has a less clean energy grid than Maine. So we're talking about a pretty significant reduction of carbon use here. And you know, going from about 48 cars a year to about, it's about 3.5 cars a year. Just some views of the building. This is from above upper campus looking down. You can see the bridge form here stretching out across. You can also see some of the centralized ERV components. This is a ventacity unit on the roof. And then here, the site plan trying to use as much as possible the local, the already established trees on site and weave the building through those conditions. That was part of the unique Conservation Commission overlay in this particular town. So we were able to take advantage of the bridge in that form too, because it actually allowed us to cut less trees, which was really, really beneficial for them in terms of meeting those goals. Some views of the interior. This is that circulation space that you saw in plan earlier, running through the second story of the building and creating the connection from the lower campus below. Reception and study flex spaces. This is a view of the all school meeting above, and then that grand salle salon space below. Just a view of the entry here, southwest facade looking under the bridge connection. You can see that stretching across here. And then that all school meeting space. Again, same number of students that were in that previous flex space, and we were able to visit them at the end of the project as well, which is great. And thankfully did not count anybody falling asleep that day. I'm sure kids still fall asleep for other reasons, but it wasn't because of the CO2 being too high. We were able to measure that afterwards and actually check on the BMS that we were in control in that main space, which is one of the primary goals of the project throughout. And just a view from the front of the building, that all school meeting space is the large one looking back at us here. And then our partners on this one, this is a Unilux curtain wall and window project, EPS and dense blown cellulose, so the insulation product again. This time we were able to use a ventacity centralized ERV, which wasn't available to us in the Corner Spring project. And so it's great to have a passive house certified partner for an ERV on this project. And then this uses an LG air source centralized VRF system instead of a decentralized system. So more advancements there. And the last project we're going to go through quickly, and a lot of you have seen these projects before, just trying to show them in a different context, is the Ecology Atlantic Center for Human Ecology, which we call An Education in Wood. This project's objectives It's the first purpose-built academic-only building in this college's history. It's only a 53-year-old institution, and they'd been occupying old residential summer homes in Bar Harbor, Maine, and now are occupying for the first time a purpose-built academic building. They have an advanced, holistic, and thorough sustainability standards, like really, really aggressive, internally established sustainability standards that we were required to meet. They had multiple competing programmatic and performance goals. Sometimes we had to teach them how those were contradictory to each other, which was a challenge, and sometimes affected the Passive House goals of the project. It has a multidisciplinary teaching model, which can be a challenge too in the design and layout. The college has a rule that they do not certify buildings of any variety, LEED, Passive House, whatever, but they had specific internal standards that required pH performance. So we're essentially running a Passive House program on it and knowing ahead that we weren't actually certifying. Very vocal and engaged and educated community. It was a previously developed site, and the sustainability goals were not always hierarchical. So not only were they sometimes contradictory, they didn't always know which one should take precedent. So we had to kind of educate them along the way and what we thought was the most important for them to follow when there were contradictions. The building layout was actually, despite its form being unique, quite simple. It's a single loaded corridor throughout the building, and the only areas of double loading are these offices that jut out to the west, and they help shade the kind of two-story corridor space that's all sunlit from the south, that kind of flows around the entire building. Again, you can see similar strategies that we're using in all these projects, where we're trying to use the corridor space because it's transient as a space to collect solar gain if we can, and utilize it. And because we know we're not going to get an overheating condition in those spaces because of occupant gain, because they're mainly going to be in the classrooms, which are facing north and east in this case. And the interesting thing here, though, is that they had these three really, really intense specific uses that had to be contended with, despite those same strategies that we use in the other two buildings. So they had a chemistry lab, which required during use 6 air changes an hour, which is similar to a surgical suite in a hospital. They had a zoology lab and dissection lab, which required 12 air changes an hour. So one of the highest levels of potential pathogens in space in any building type is a space where you're dissecting other species, because you could have unknown pathogens that are not even something that we necessarily recognize. So that's 12 air changes an hour, and these things could be happening simultaneously. Then they also had this working greenhouse, which required its own, for its programmatic purposes, direct exhaust and makeup air. And so the decision was made early on, like the greenhouse is going to be its own thing outside the thermal envelope. It's attached to the building, and we measure its energy use, but it is not contributing any thermal load to the building directly, except through its proximity to that exterior wall. So you're letting the exterior wall run all the way through, and the greenhouse be a separate space from the rest of the building. And then the more intense lab spaces were managed just through a really intense ERV. So in this case, we're calculating that 40% of our energy loss was directly through ventilation because of those high air changes. So we designed, our mechanical engineering team, Van Zelm out of Connecticut, designed with us a 30-foot long by 9-foot by 9-foot square ERV with a custom enthalpy wheel that was capable of handling and modulating these changes throughout the building throughout the course of the academic day and calendar. Takes up this huge space in the basement, and pretty intense thing, pretty cool, metal box. And so what that meant overall is, on a project like this, academic building with lab spaces, the average is about 120 kBtu per square foot per year on a national average, current national average. Again, same Passive House target for academic buildings. We were modeling, with renewables, a EUI of 11 kBtu per square foot per year. And after 1 year verified, we were tracking at 13.6 kBtu per square foot per year. So really happy with the measured performance of this building. Really exciting to see that even at scale. This is a 30,000 square foot building. We were able to hit those targets. This one, we're looking at 24,000 kg CO2 per year in emissions, operational emissions, down from the use of approximately 50 cars per year is the equivalent of a national average building of this scale, again, per year. So if you think about the duration lifespan of these buildings, quite significant, down to, just under 6 cars per year. So huge significant savings in emissions. Again, our overall goal is to try to strive for that. And we're able to put that into common terms for them about how that would affect them. And it'd be essentially their entire school community giving up driving for about 5.5 years, which is kind of crazy. It's pretty significant. Also, just some really unique opportunities to engage with systems that you might not typically use in Passive House. This is the chemistry lab that has all of these hoods for their chemistry experiments, and we were able to use recirculating hoods with custom designed filters for their specific coursework, rather than just assuming that we're going to go to ducted hoods and having a makeup air issue, non-tempered makeup air issue, and things like that would be normal for a chemistry lab. It turned out that despite some initial resistance, it totally works just fine. They were able to get all the chemicals that they wanted to use, specifically dialed with those carbon filters for those specific hoods. Building came with other challenges. They wanted to do an all wood system. This is one of our early all wood insulation projects, and kind of hybrid mass timber building before we've kind of shifted towards more full CLT and glulam. This was a glulam and solid wood building with wood fiber insulation. That was atypical for a building of this size, and the contractor was a little skeptical that you could do a building this big, literally in wood, but we did, quite large. And also things like bird safe glazing and things like that were kind of new products, trying it out in addition to going for that Passive House performance. So just some quick views through the building. Again, it's a project I'm sure many of you have seen before. Really, really exciting, wonderful project, and beautiful design as well as performance. Just a shout out to our partners here, our product partners, the Unilux curtain wall windows with Ornolux bird safe glazing, Gutex wood fiber insulation in this case. This is pre-timber HP and dense blown cellulose in the roof. Mass timber construction, as I mentioned, custom centralized DRV, and it's once again an LG air source centralized VRF heat pump system. And that's it for me. I thank you guys for the time.
So I am the Director of Sustainable Design and Resiliency. I've got the longest business card ever because we sit in the Technical Standards and Support Group, which is part of the Design and Construction Innovation Management Studio. And I am actually the second certified Passive House designer to have this role. So context, 1,800 schools and 1,400 buildings, more than about a million, a little less, about 980,000 students. Then there's staff, so about an eighth of the population of New York City uses New York City public schools. We're building 7 to 10 new schools a year, 7 to 10 existing school electrification projects per year, and scores of renovations. It's a lot of work. And so SCA continues a lineage of innovation that goes back to kind of the beginnings when it was still part of the Board of Education. This is Stuyvesant High School by Charles B. Snyder, who was the superintendent of schools. He was a firm believer that schools could be cathedrals of learning, and he was an innovator. He prioritized things like fire protection, emergency egress, large windows for light and air, and simplify the construction. Like he standardized things like steel frame construction and simple shapes, H's, C's, I's, L's, and all with an eye to maximizing the environmental exposure for light and air. He also instituted kind of standardization, a kind of a proto assembly line process for design to churn these out. Under Snyder, they built about 400 buildings, 140 elementary schools, and lots of other like buildings. So he was kind of the Christopher Wren of public schools. This is the context. So, and actually going back to this, so in this idea of like standards and innovation are kind of at the core of what we're doing at the School Construction Authority to this day. This is the legislative context within which we operate. This is the legislative in the last 20 years, like we've seen just like a whole slew of environmental regulations come in, and two of which, like Local Law 97 for the carbon emissions reduction mandate, related to Passive House. One of our New York City Passive House designers, Stas Sachesky of ZH Architect, like when they were doing Local Law 97, he actually documented that the buildings that he was doing in 2019 were satisfying the 2050 requirements for Local Law 97, thanks to Passive House. And Local Law 31, which is an update to Local Law, so Local Law 51 is an update to Local Law 31, and it has basically a Passive House mandate. So this is some of the text from it, and if you look here, right, this is a Passive House number. So this idea of simplicity of form and speed of design and construction is still central to the way we do things at the School Construction Authority, and the process is really based on standards. We have a whole series of design requirements, and actually all of this is on our website. We have standardized specifications with particular manufacturers indicated in products, standardized details, room planning standards, and the Green Schools Guide, which I am kind of the director in charge of, is also part of that. And this is the stuff that governs all of our energy use. And if you notice the sort of the simplicity of the form, it's like what you always hear the Passive House, the PHI people talking about Passive House forms, these kind of simple volumes. So as per Local Law 51 and Local Law 31 before it, like all city buildings are required to meet LEED Gold or equivalent, So when it was first put forward, there was no LEED for schools. And it was very difficult to kind of navigate it. So the SCA was allowed to develop its own standard, which was the Green Schools Guide. And it's what's kind of nice about it is that there's a whole lot of other requirements that we're required to comply with, things like the climate resiliency design guidelines and other aspects of local law and executive orders that we choose to comply with. And this becomes a kind of more compact way of ensuring all of that that LEED wouldn't actually do. So in the past decades, we've dropped in a school energy use for new school buildings. We've cut it in half. All of our schools now are fully electric. Existing schools are being electrified, be given deep energy retrofits. And related to Passive House, we've given 200 employees out of our 1,000 CPHD training. We do a lot of research. We do a lot of to verify and support our development of new standards. So we've done a lot of envelope studies. We're looking at equipment. We've done demand controlled ventilation, studies on hot water, photovoltaics, building integrated PVs, and battery storage. So we're really trying to push the agenda. This was one of the most influential studies that we've had to date. This was done by FX Collaborative and Stephen Winter Associates. The link is on the SCA website. And we looked at a whole bunch of energy conservation measures. These are some of the envelope measures, right? This has led directly into changes in our standards. You can see that the EUI reduction, which in our case is actually source EUI, like what the measures actually produce in terms of EUI reduction. So you can see that the wall upgrades and the lower glazing, right? And that has brought us to instituting rain screen assemblies with robust exterior insulation. Through that study, we determined that sort of most cost-effective is like an R30 walls, R40 roof, triple glazings through the vagaries of our getting into our specifications and what manufacturers we can include. We're looking. We've cut down by a third our energy use from the energy code on Windows, and we've done a lot of thermal bridging mitigations that have actually made a big difference. So some of the next steps. So one of the things I've been looking at, and is actually Jeremy, my predecessor, this was one of the first things he took on. He was trying to bring in European manufacturers, and it's looking like it's finally we're able to start to push towards that 0.13. It hasn't happened yet, but it's coming. Optimized wall and roof insulation. The standards come about because we're largely prescriptive here because of the turnaround times. And this was actually a question I was going to ask to some of our panelists about their turnaround times and the modeling requirements. Thermal bridge analysis is something that we're looking very carefully at to improve, particularly the window thermal bridge, that psi value around window openings. Enhanced commissioning, that's the CX, then the air barrier testing. Currently, we have a visual testing primarily, which everybody who's in Passive House knows that that's really not sufficient. So we're pushing pretty hard to see if we can institute that. More HVAC improvements. There's a lot of push towards VRFs, but I'm not entirely positive. It's the way. Dominic is going to talk a lot about his experience with this in a minute, so I'm going to leave him for that. And revising modeling requirements and revising energy use targets. The modeling right now, I don't feel that we are doing enough to substantiate things, because potentially, given the form factor of an individual building, we maybe should be reducing or increasing insulation amounts. And so we're not really quite doing the job that we need to do in terms of the modeling. And that kind of leads me to the last thing, a little bit of architectural theory, if you guys are familiar with this, and particularly the second edition, which has kind of the most interesting, like his forward there, his introduction is pretty interesting, right? And this idea that architecture, because I think a lot of us in Passive House are very much architects, although there's quite a number of engineers that we have just been educating here at the School Construction Authority in this, that there's this divorce between architecture in one place and technology, particularly a technology of comfort, is in another place, and that the architect shouldn't be kind of like engaged with it. And it's been a detriment, right? So and he notes that it fell to another body of, let's say, men and women to assume responsibility for the maintenance of decent environmental condition, right? And it's another culture. And I think that one of the great things about Passive House is that it really is this bridge between it, where like we really get to geek out on the technical things while supporting an aesthetic agenda. And I think that one of the problems we've got with modeling right now is that modeling is very much a province of experts, and we're not really bringing those experts into the tent well enough, and we really not allowing enough agency responsibility, let's say agency and responsibility about the onus of participating in this, and that there are tools that can allow the individual designers to inform their decision making during the design process. And I would really encourage that kind of thinking to take hold. So with that, I'm going to turn it over to Dominic.
First, just want to introduce you to Architecture Research Office. We're a 40-person firm located in New York, and we just celebrated our 30th anniversary this past year. We have a diverse body of work, from a new mass timber building for UW Tacoma to the restoration of the Rothko Chapel in Houston to material research for Philsfeld. Research is our middle name, and our design process is really just a form of research and inquiry. Research gives our work purpose and intention. Our introduction to Passive House happened a few years ago. It was through a collaboration with Della Valle Bernheimer Architects that was completed in 2010, called Our House in Syracuse. It was a single-family home designed as a prototype that could be implemented throughout a neighborhood. Following the success of Our House, I think we, much like Opal, wanted to challenge ourselves on our next Passive House project. And so we jumped up a few scales and went with the Khalil Gibran International Academy and PS 456, which I'll be presenting today. There are two schools, new schools in downtown Brooklyn. The schools are part of a larger redevelopment with Alloy Development and the Educational Construction Fund, a city agency that partners with developers to build public schools. We work closely with the School Construction Authority throughout the design process to meet design requirements. And as we kind of all know, these projects are complex, and you need a really collaborative team working together to make sure that you can achieve Passive House performance. So really everyone on this team here, from the envelope consultant to the structural engineer to even the food service consultant, had a part in helping to design this Passive House schools. So here's just an overview of where the schools are. Manhattan's on the top, and Brooklyn in our site is in this blue circle. Zooming in a bit, the schools are located in downtown Brooklyn, an area that has seen really a remarkable transformation with new development in recent years. Flatbush Avenue is on bounding the site on the north is one of the main thoroughfares that basically runs from one end of Brooklyn all the way to the other end of Brooklyn. The site is actually on this really interesting threshold between downtown Brooklyn with all these new towers and developments and the Brooklyn Academy of Music and sort of this cultural center. And then on the other side is Brownstone, Brooklyn, or what people imagine of Brownstone being like different scales. So this really interesting hinge point, and it was critical for the project to really mediate between these two different conditions. From a planning standpoint, basically Alloy Development had a pretty simple strategy. Basically, they want to preserve these historic structures that were already on the site. The structures were the existing Khalil Gibran International Academy, which I believe are the oldest schools in the DOE's portfolio and over 100 years old. And they're working in two phases. The first phase is to create a mixed-use tower, which will be Brooklyn's first all-electric tower, 100 Flatbush, and then two new schools, a home for the KGIA, as well as a primary school, which is K through 5th grade. And so that'll be phase one. And then phase two, once KGIA and the new school open up, they'll rehabilitate the existing buildings and build a second taller tower directly adjacent to our school. So at the center of the block are these two new schools. I think Caleb touched on this earlier, but local law was really one of the things that kind of drove this idea of how can we use this as a pilot case or test case to see how efficient a school you can design to hit this local law 31 target of 38. And so basically we worked with the school construction authority, the developer or design team, really to kind of use this as a test case, find a way to hit that target and potentially show the way to build sustainable schools for future SCA projects. From a programmatic standpoint, we had 500 seats for the primary school, 346 seats for the high school, and a number of shared components. About 40 classrooms in total, 2 libraries, science labs, a gym for the high school students, competition-sized gym for the high school students, as well as a gymnatorium, which is a gym and auditorium for the primary school. And then one thing that this school also has is a kitchen, like essentially a commercial scale kitchen for both the high school and the primary school. Here's just an overview of the site from the primary school from State Street. So here's this axon view. There's an entry off of State Street. We used the setback, the required zoning setback, to create a play space for the primary school with the sort of rainbow colored roof. And then like this play enclosure represented a number of challenges, interesting challenges to prevent thermal bridging. So I'll show some details there. And here's just a view from street level. And really you can see that this context is much different. You have this cantilever floating volume and then glazing on the ground floor to invite views into the public spaces. Whereas the high school is entered off of Flatbush Avenue and bounded by retail on either side. At the setback for the high school was high school terrace, where good students are able to go and have meals after during lunchtime. And so from the street, you get really this sense of scale of the building. We wanted it to have a presence amongst all these towers. And so really creating this object, this floating object along Flatbush Avenue that can be seen from both directions. Flatbush Avenue, for those who haven't been there, is very loud. It's essentially a very slow-moving highway with 6-lane highway with cars, buses, trucks, and lots of honking. And I think one of the great things about Passive House and having to achieve Passive House performance in your envelope is basically the acoustical performance that that robust envelope provides. And so we kind of needed to have that triple glazed windows to both deal with the honking as well as the thermal performance, all in the goal of kind of creating this positive impact on the interior learning environment. Here's a section through the building. So essentially the primary school and high school are stacked on top of each other. We had a large gymnasium on one level, upper level, and then the gymatorium was on the cellar level. And both the primary school is essentially oriented towards State Street, whereas the high school was oriented towards Flatbush Avenue in downtown Brooklyn, because the energy of the high schoolers they thought was a great way to kind of connect to that. Our Passive House envelope is also kind of shown in this blue line. One of the things, there is a retail component within the program, and we excluded that from the envelope. We still have a robust Schuko storefront system, but we added an air barrier, an interior air barrier for the testing purposes. I'm also showing the envelope performance targets that were set early in the process by Thornton Tomasetti, our Passive House consultant. We had a R50 roof, R30 walls, R20 insulation, and then foundation target, and then for glazing, a U value of 0.14. So here are some views. The project is still under construction, so no photos of it yet, but here's views. On the upper left is a view of the high school entry, and the upper right is the PS entry. And then the bottom, you have views of the gymnatorium in both gym and auditorium function. I think the really just kind of creating these welcoming spaces, daylight filled, but also robust envelope performance, kind of finding that balance between those things. So the facade is primarily a brick cavity wall with punched window openings that offset from each other as they move up the building. This is going to Caleb's point earlier, the typical school construction authority wall assembly detail. However, we introduced a new thing, the thermally broken brick shelf angle at each window head in order to mitigate thermal bridging at each of these conditions. So here's just a blow up of the window head detail and then window sill detail. So R30 insulation continues throughout. We used a ferro bracket system at the window heads, and then made sure that we had that insulation continuity. I think the masons always want to return the brick all the way to the CMU, and we had to make sure that there was some of that insulation continuity as they were building up the facade. Caleb also touched on this. So in order to hit those targets, we had to go with the Schuko system, tilt-turn system as our basis of design. It was a really critical component. I think we had a nice balance of window wall ratio, not too many windows, or not too much glazing on the project, but we did have 240 windows. So I think it was critical that the detailing and testing those, the installation of those windows was performed correctly in order to ensure that the facade performs correctly and passes the blower door test. In addition to that brick cavity wall, we had a number of typical conditions. It wasn't all brick. So from a shallow foundation system to deep foundation system for future towers, to retail storefront, to basically CMU at these lot line conditions between the phase 1 tower and the school, and the phase 2 tower and the school. We had a lot of interesting problems to solve and interesting challenges to solve. And so I think the lot line CMU walls were probably some of the most difficult things to deal with. Basically, due to like sequencing, we had to essentially use a closed cell spray foam insulation on the interior of the CMU. Here's a therm diagram of that condition. We had to account for all those linear thermal bridges at each slab level. And thankfully our envelope was robust enough in order to deal with those. And then it came at those moments where basically the brick cavity wall, the typical brick cavity wall, transitioned to a CMU lot line condition, making sure that the air barrier stays continuous was an interesting challenge. I think our facade consultant worked on was able to develop some nice details that allowed the air barrier and sequencing to deal with like basically shifting the air barrier from the exterior of the CMU to the interior of the CMU. And here just kind of some initial details on how that transition worked. Minimizing thermal bridges, I think every school is going to have them. And we worked closely again with our envelope consultant to try to mitigate those and minimize them, from basically the typical parapet wall with thermal break material to dunnage conditions where basically we introduced a thermal break material in the center of the insulation, to like the play enclosure structure when it needed to frame back into the structural system, providing those thermal breaks. From a PHPP standpoint, here's just an overall summary from Thornton Tomasetti. We're under on heating demand and cooling demand. And you can see that primary energy number, we're above the PHPP target. I think early in the process, we sought ways to like really get the primary energy below the target by including the cafeteria process loads, but really were unable to achieve that. And so I think in discussion with PHI, they looked essentially at our model and were taking the process loads out and accepting that the 27.4 kBtu per square foot per year would be what that source EUI would be. And so breaking down the energy a little bit, the primary energy loads, you'll see that like cooking has essentially 35% of the PE loads. We have lighting, plug loads also are a large portion of it, whereas like heating and cooling are very similar for the school. So I'm going to quickly get through this so we have time to talk about the projects. Here's just some quick work in progress. Here you get some shots of the ferrule bracket with the CMU backup assembly, our fluid applied membrane system. Here's just a view of the insulation going in, the brick cavity wall insulation, and then we have a closed cell insulation. We used a Huntsman product that had a low global warming potential of 1. And then basically this is a lot line CMU condition. Since essentially the closed cell insulation was stopped at each slab edge, we had to kind of essentially have I would say belt and suspenders of this air barrier, fluid applied air barrier at each of those slab edge conditions. Here's windows going in, as I noted, 240 tilt-turn windows. So like attention to detail and making sure that they install the all the sealants and membrane transition membranes was critical. Here's some views of those thermal breaks for all the different systems, the play enclosure, and here's some views of our Swigon ERVs. We had 3 of them on the project. We worked closely with Stephen Winters to be the commissioning agent for the Passive House. So they've helped guide us through the process. They've dealt with a lot of really large Passive House certification process projects. And so I think testing throughout the construction process has been critical. So here on the left, them testing that first window that went in to ensure that you know, it performs to spec. Then isolating a floor or a section of a floor and doing a guarded blower door test to see like how the envelope's performing, and using theatrical smoke to find where there are leaks has also been critical. And then coming up this summer, we're going to do the whole building blower door test. So that will be coming up in the coming weeks. Here's just a view of the completed envelope. So site work is wrapping up, and we're quickly approaching the school opening up in the fall in September. And here's another view from Flatbush Avenue. And thank you.
Fabulous. It's great to see this mix of projects. One thing that jumped out at me, and please, folks, put questions into the chat. I think I've got a couple here that I can pull out as we go. One thing that came up again and again was kind of like the educated consumer, the client who's interested, asking for it, what the, you know, who's selling who, and where is it going, but they're all slightly different stories. And I was curious, I guess, in terms of the first project from the Friends School, either from you, Naomi, or Richard, you know, where you see that project, and obviously other school projects happening in Maine in your neighborhood from Opal and others. You know, where's that conversation going? Is it, and do we, you know, are people being educated about this? What do we need to do to move it to other, you know, to other public systems? It seems like a private school is a sweeter spot in terms of control, but we'll flip to the public in a second here too. Any thoughts on that?
I have thoughts about that, because with my Passive House Maine hat on, I'm thinking about that a lot. Like, how do we push that? And I mean, I do sit on committees for the Maine Climate Council, and trying to push the green schools agenda all the way to a high performance building. But they're, yeah, as you say, the boardrooms of small private schools are more easy to get everybody on the same page than well, state government, let alone town government, which might even be the more difficult lift. So unless it's really mandated at the state level, there's a lot of potential for pushback at every phase. But I think as we, as the multifamilies in Maine are required to be built to Passive House standard, there's just more familiarity. I think I'm amazed whenever I meet somebody new and introduce myself, they know exactly the Passive House Maine by name. And so there is a lot more public awareness of Passive House and of the need for upgrading our buildings as part of our approach to not just climate change mitigation, but adaptation. And there's so much delayed maintenance and retrofits required on top of that. So I think there's potential, but we're not quite there, is my summary.
Yeah, makes sense. Richard, anything to add there?
Sorry, thunderstorm and an enormous thunderclap right above me. No, I think I'd really be just reiterating what Naomi said, but from the architectural side of things, in that, yes, that's the experience that we've had, is that the smaller private schools and the experience of my firm is has easier tilling ground that bears fruit, if I'm mixing my metaphors. And the office is actually going through a conversation at the moment exactly along these lines. How can we have a broader reach with municipal and government projects for and bring Passive House along? So that's a challenging area to work in. But we've seen the benefit with the smaller private schools. Would like to have the opportunity to take that further, for sure.
Right. Well, before we get to the public schools, Tim, your thoughts on, you have clients who are asking for it, but they're also asking for a wide range of sustainability goals. And how are you juggling and balancing? I mean, you spoke to it a little bit, but push comes to shove and decisions need to be made. Where do you see the clients, like, what are they clinging to or really demanding?
Yeah, I mean, I think that it's related to the question that you asked Naomi and Richard, that, I think that I encourage everybody in the seminar today, if you're in the room at those early meetings, and the architects on the call are certainly in the room in those early meetings, it's a chance to put on your design hat and think about, like, what is the way in for this client? Like, how are they making decisions? And think abstractly about that as a design problem, so that you can use the benefits that we all know that paradigm like Passive House or broader kind of whole life emissions approaches can offer them to solve those unique problems, which sometimes are completely irrespective of whether what the governance of that institution is, whether it's public, private, whatever. And so I think that we have those tools like in our mind, but sometimes we can be kind of slaves to the exact program that we're trying to use, like say PHPP, or if it's if it's LEED, or if it's somebody going for ILFI, zero carbon, or something like that, and rather let's think about building the pathway to the end outcome that the client needs, and inserting the frameworks along the way, sometimes without asking. One thing that we've always done is just say, well, Passive House design is what we're going to do on every project, and we're only going to address it if they ask about it, but they're going to get it anyway, right? And that is an easy way to get 90% of the way there, whether somebody asks or not. And to me now, that's the same lesson we're trying to take to these kind of holistic sustainability approaches. So, a lot of our clients now are interested not even just in the private sector, but interested in, well, what's this whole carbon thing about? I'm like, well, turns out that all that energy you were concerned about 10 years ago is just one component of WLCA. And like, we're now looking at that much more holistically. And yes, we can help you there. And guess what? We were already gonna anyway, whether you asked us or not. And to me, that's like, all of a sudden then your design mind becomes a tool to solve specific problems that clients maybe didn't think were even related to Passive House, to sustainability even in general. And that to me is the pathway to actual holistic successful outcomes that serve everyone, the community that's going to use the building, and us as designers trying to push forward a program that we know is beneficial to society.
Right. Shifting to the public, I guess there's a question everybody's wondering is how, well, one, just this great appreciation of trying to turn a super tanker that is the New York City school system and construction authority And then we have these two pilot projects happening. Can you speak, both of you, Dominic and Caleb, speak a little bit about how the pilot projects came about, and what potential do you see them in moving the needle going forward? Because obviously we see like getting out of the prescriptive, as you spoke, Caleb, and moving toward modeled performance as being an interesting thing. And then I've got a follow relating to another question. Yeah.
Yeah, I mean, Dominic can actually tell you much more about the structure of it, but basically, School Construction Authority was not the developer of those schools. It was directly contracted with, I think, the Department of Education. That there's my age, Board of Education preceded, and the developer. And I think the developer was the one that, in this case, pushed for Passive House. And there's something of a reluctance, and my boss keeps having to sort of tamp me down. Take your time, take your time. You've only been there 6 months. But it is, and there is, I think, a reluctance, and this was actually going to be a question I put it in the chat for Tim about, like, doing the modeling, doing the math, doing your homework, and like even on a tight timeline, like, does that hold you up, right? Like, there is a reluctance. Everything becomes an additional services, so there's a cost implication to requesting things that go beyond the prescriptive requirements. So I'm very curious with Dominic and whether they actually, ARO looked at what they would have been paid by School Construction Authority to do the same project.
Let's talk about that offline, Caleb, for the next project. But I think, though, the city incentivizes like developers to build better, and so there's the City of Yes new zoning resolution that basically says you can have this ultra high or low energy use intensity building, and basically sets a Passive House performance. And so that recently was passed, and basically if you perform to that level, you can get a 5% overall deduction in your floor area, and so you can build more. And so that was passed. We had filed under a separate version of that, the project under that, but Alloy said, no, this gives us more floor area. Let's see if the school meets that criteria. And so they're willing to pay for that additional services or like additional modeling time in order to prove out that, yes, we're building this ultra low energy use building. They need to work on the wording of that, but and it pays off. Like, and so I would also note that I think Ken, you called it changing the direction of a tanker. I think the School Construction Authority, they design buildings, and their standards expect buildings to last for like 100 years. And so there already is this robustness in their design. I think, changing out the windows or adding a little bit more insulation to hit Passive House targets is like just a slightly nuanced approach to a building. But there's already this sort of expectation that you're designing a robust, very robust building that needs to perform for a lot of people for a long time. And so that durability and the attention to details is already baked into like what the city expects from their public schools. And so it's nice to have a client that wants to have a building that performs that long and work with them. And so I think echoing what Tim was mentioning, that like approaching these projects with like just like Passive House concepts and like being smart about it, like should be like table stakes, like how we approach every project. We shouldn't be having to like sell the client on it, but really just like that's how we should be designing and every project. So
Yeah, and actually,
Caleb, I'll answer your question too after when you're done.
But I'm going to throw it out. I'll throw it out.
I was just going to actually say, like, one of the things that Richard and Naomi said that like is very much like at the heart of what we do at SCA is that you have to keep your detailing actually very simple, because of like you don't know necessarily the nature of the contractor, and you're really having to work with the systems that are already there, both from the people who are building it and the people who have to maintain it. And that's actually, you know, between those things, it is the tanker, right? Like trying to shift all of this stuff into high performance.
Right.
And then Tim.
Yeah, so let's combine a couple questions then, because Caleb, you brought up another aspect. So on the process and the modeling and optimization to passive house could be a little bit more complicated, perhaps, maybe not always, depending on what the initial brief is. But the 3 projects, I think, illustrated, you know, different creative tensions, if you will, with the Friends School of Portland, where you're drawing it out, like to see what's going to be able to stay and how you dealt with that in the optimization. You also have school schedules. So the School Construction Authority, as a school schedule, schools have got to open. It's not, and I imagine that's true for any school that's doing this kind of capital outlay. And so I'll bring it back to Tim to answer the question first, but then others, if you'd like to add on, please do. And then I'll pair right into that. This idea of conventional construction, where we've seen it on different projects where we're tweaking really conventional construction and seeing how to meet the market where it is, and deliver passive house performance, and then steps away from that depending on, you know, the environment. And so what do we see and how do we affect the process? Like in New York, you know, 3 prime bidders or whatever, and different primes for the different parts can really complicate the construction process. So Tim.
Yeah, I mean, as far as design process, to your question in the chat, Caleb, and then the expanded question, Ken, is the way you framed it is, I mean, I think about, I really love the quote you put up in your portion of the presentation, Caleb. A lot of people don't know this, like I came from a theory background, not a tech background. Like I went to design, you know, high design school, not a tech school. And to me, it's like, okay, like the technology is integral to the discipline that we've chosen as artists, as architects, and all we're doing is saying, okay, the problem of the day and the criteria that we're trying to shape when we design the built environment now has different inputs. Those inputs aren't, you know, the spans of steel and concrete like they were in 1920 that everybody looks back on now as like high modernist design. Well, those are technical requirements too that had to get adopted and synthesized with architectural practice, design, and theory. And to me, the energy model is the same, right? It's a tool that changes the way we design a building, potentially, if we listen to it, look at it, and treat it as such, and don't treat it as this like separate thing. So we came to Passive House really early. We certified our first Passive House in 2010. And we were trying to develop an internal energy model that was as simple as possible, so that, and as close to PHPP as possible, so that we could use it on every project, and we still do, right? So no, it doesn't change our schedule ever, you know, because we're doing an energy model as soon as we have a concept layout. And we'll put in placeholders if we don't know the detail yet, fine. And we'll go beyond if somebody wants to go to certification, but we have enough confidence now that our internal modeling will be close that we don't really see it as a risk. Now things start to change as people start to ask for more, right? So WLCA is definitely changing that right now, and methodologies are still developing. But my mindset is definitely that that's just yet another input, right? I'm excited about it as a designer. I'm like, great, you know, okay, we have new criteria. I can switch some other things to being constants and have new variables to play with. And that's going to produce new exciting architecture that's different, that looks different. And that just excites me. So I always want to adopt it. It's probably a bad business decision because it means less ad service, but I think it's proven to be a really successful thing for our clients because they're getting something that's critical, has a great outcome that benefits them, benefits their community, and they're not necessarily having to pay extra because honestly, it shouldn't be extra in my mind. It's just the way we should be designing. So how you transition it into construction outcomes, I'll let somebody else answer that. I have my thoughts. I'm going to shut up though for a bit.
Yeah, and there's like no structure is designed without structural software these days, right? So why should we be like, why should we not be doing this? And it seems to me that the structural software could actually give us like, because 90% of like embodied carbon is in the structure, you know, and so like the engineers could actually be giving us that number, right? It could feed right in. And so I don't see why like energy use is something that should become an additional service. Although we are actually required to model at 60% and 100%. And the model, but through eQuest, right? Whatever. But like the modeling recommendations, it's not being used to kind of version and fine tune, which I think is really kind of an important aspect that is really the critical part that we get. And it's not actually because eQuest doesn't really look at thermal bridging. We kind of use like tables for like derated R values for the assemblies in eQuest, right? It's not doing the job that like Passive House Planning Package can do. So we actually kind of need to have, but it doesn't give us sort of the better specifics in terms of hourly consumptions and loads that PHP doesn't do that you get out of eQuest. So there's like benefits to a whole bunch of different things. And it would be nice if we had a single engine input or some kind of like universal translator that could actually take the inputs from one and stick it into another.
Yeah. Absolutely. Dominic, I don't know if you want to add anything to your like as an architect working on these two schools with the optimization and the energy modeling, did you feel you weren't doing it in-house, you were doing it to consultants?
I think our school was very complicated, and we had to work closely both with Costantini, our mechanical engineer, and Thornton Tomasetti really to make sure the systems and Passive House performance were all jiving. I think like Caleb noted, we went in with the project saying that it had to be a VRF based system in order to hit the primary energy target. And basically the school construction authority said, no, we don't do VRF systems. And so that was like an early challenge for the team. And so there was a lot of back and forth to really work with a VAV system. We have like very, very efficient chillers. So we have a cooling tower. And so it's I would say potentially overly complicated, and would have been great to just approach it with the VRF based system. But I think it was critical to have kind of experts from TT and Costantini and the SCA and ARO like at the table to understand the implications for those things. And so, you know, there was with the VAV system, there are architectural implications. There's lower ceilings, there's more ductwork. And that those are all interesting challenges that we had to deal with as a team.
Yeah, great. Your volume dropped off there. I don't know what, but we can still hear you.
Oh, you can hear me?
Okay. Richard, as you and the firm worked through the design of the Friends School and that process and the pressures there, as well as the conventional construction and bringing that to bear. Any thoughts on those?
Not really additional, I think, to what Naomi and I mentioned earlier. We like the all wood construction. We minimize the steel work. It's a relatively small project for a small private school. So none of the spaces were large, none of the large spans. So it really felt like it was a large residential construction. That made it very accessible, I think, for the builder and the whole design team. There is the challenge to try to do something that's a little elevated, try to find some spark and inspiration when the basic tools are so simple, if you like. But that's also a very nice challenge.
Yeah, let me turn that to this. I know we're running a little over here. I think this will be the last round, and I want to bring it back to something I was struck by all the projects, and that is, the architecture and the use of natural light, and this idea that we just don't have buildings wrapped in glass and form, and starting back with the Friends School, we'll work back the other way. That just those interior images and the way you use the glazing and positioning it in relation to the spaces and everything. Just to me as an architect, and appreciating that, just bringing it to life and seeing the variety from project to project. Maybe just speak a little bit about the form making, the tools, and I think to tack onto that, not to draw this out too much, but this idea of like increased attendance, increased productivity, lower costs, like happy owners, happy students. It seems to come together. Richard, do you want to continue, and then
I think the increased attendance and excitement, certainly with Friends School, I think it underscores the clarity that it's not just architects who are hoping to find, these wonderful projects. I think there's a wider community out there that's just crying out for them. So when these new schools become available, there's a large pool of people who say, that's where I want to send my kids. That's the sort of a school environment that I want to be involved in.
Yeah, I was going to say it's the parents that were in the market there rather than the children, in a way. Like, we were really trying to, they're the ones that are making the choices. But yeah, I'll just say for Friends School, we had 94% of all of the wood trim came from on site, and that was important, as we said before in the beginning of the design, for sort of honoring the land, but then also creating this interior space that was just so welcoming and beautiful, like that. The big room, which functions as both the meeting room and the gym, is my favorite room, like, ever. It's just such a lovely space, and a lot of that is because of the materials used and the environment that's created.
Fantastic. And Tim, your use of a light and form and these buffer zones and the balance and all of that.
I mean, to me, it's like schools, higher occupancy buildings in general, mixed use occupancy buildings, schools are a great kind of, I'd say, bridge between housing and houses to kind of more complex public buildings when we think about a passive house paradigm. And all of a sudden, because of the way occupancy works differently in a high occupancy building, it allows for the much greater potential for light than we would typically expect in a passive house. And that's so important for education, for biophilia, for mental health. I think what we saw was that, you know, as horrible as experiences it was, the pandemic became an amazing didactic tool for teaching people why these educational spaces are so critical, and their indoor environments are so critical, not just to have great fresh air. The passive house delivers clean air through filtration, but also just calm spaces that allow for mental health. And it turns out if you're using really good glass, you can use a lot more of it. And all of a sudden you can see out, and all of a sudden it's not a dreary place to be, and kids want to be there. It's like, it's not rocket science, but you know, it's about kind of focusing on the things that we all know through this paradigm are important, and then figuring out how they can be leveraged when the model shifts to something that's advantageous for glazing rather than maybe restrictive for it in a residential context.
Yeah, great. And Dominic, I've had the pleasure of touring the schools earlier in the year, and I just love the punched openings, and you know, and realizing like the quality of daylight in the classrooms. You don't need massive glazing to get that play, and then the volume set off the street with the glazings. Talk a little bit.
Yeah, I think we want to create that really just a comfortable learning environment, you know, not too much daylight, really the right amount of daylight, fresh air, resilient, and also just kind of pointing towards something that like it is a civic monument to like education. Like it has this presence along Flatbush Avenue, and like schools are very important, and like it wants to announce itself, and so like that was something that we thought was very important. Like it has a presence on State Street that is more subdued potentially, but really it's there. It's at the heart of downtown Brooklyn, and I think we want this thing that kids will be excited to go to and call their own. I think the students from KGIA were excited to have like their current building is not accessible. There's no gym, there's no cafeteria, and so to be able to like design something that can have that positive impact and really get them excited about their high school experience is really special, and we're excited about that. And I think like just really kind of using it as this pilot, and hopefully Caleb will take the baton and push all those future SEA schools forward, and you know, go all electric, think about embodied carbon, and like really improving performance so that that the next school is better than this school.
Yeah. So I guess the last question is to you, Caleb. What are you doing with the passive house baton?
Oh, well, we just, as I said, it's slow. We're continually trying to improve things. You know, like I got Dominic's like presentation. I was like, oh, let me see those window details, right? And actually, like one of the things like at the last to put a plug for the next Passive House Network conference, right? Like the last one, like the Akira windows by Morrison Hirschfeld, like that detail is something I've been actually trying to institute, because he did this fantastic study showing the punched window openings in that it is the single largest thermal bridge in any building, like by far. I mean, the math was incredible on it. And air sealing, I think I mentioned that before, right? So generally pushing, and then just examining our modeling studies. I've been talking to all of our modelers, like, how can we encourage like more modeling to happen earlier? And the new version of LEED, and also one of the LEED pilot credits actually cites Passive House as one of the options for satisfying the LEED and that LEED energy credit. So I'm looking very seriously at that and how we can actually bring that in, so that Passive House, the Passive House planning package, the Passive House process can actually become part of like the satisfying. And so for those and actually ZH Architects has they're doing some renovation work, right? So I kind of felt like it was bringing a Maserati to a go-kart race. And I'm hoping that it's sort of like he's getting into the tent, and that like IARO hopefully will get like some schoolwork from us and be able to apply the things that they learned. So, I have no control over who works for us, right? But it's like when I see people that are actually fighting the good fight, I'm like very happy to support them in any way I can.